Hello there and welcome to Science for Sleep, a space where curiosity takes its time, where questions unfold gently, and where the strange and fascinating edges of science are shared in a way that won't hurry you, but might settle you into a quieter state of mind. Tonight we're stepping into a question that feels almost too big to hold, and yet it rests so close to us that we carry it every single day. Is your brain connected to the universe? It sounds like one of those late-night thoughts that drifts across your mind just before sleep pulls you in. The sort of idea you might smile at, dismiss as whimsical, then realise is rooted in something real and surprisingly measurable. Before we wander too far, I'd like to ask you something small and personal. Where are you listening from right now? Are you tucked into bed in a quiet room, or maybe lying back on the sofa with your phone resting in your hand? Can you hear traffic outside, or the hum of an appliance, or perhaps just silence? The reason I ask is because we're about to explore whether those everyday sounds, the thoughts forming in your mind, and the body that holds you might have a deeper link to the fabric of the cosmos than we usually notice. It's a fitting question, because no matter where you are, the atoms in your body and the sparks in your brain are already written into the story of the universe. And if you find this gentle journey comforting, if the calm rhythm of exploring these ideas helps you wind down, I'd be grateful if you tapped the like button or even subscribed. It allows this little corner of the internet to reach others who might also be looking for something steady to listen to before sleep. A quiet pocket of science where the goal isn't to rush, but to rest. So, let's begin. Imagine your mind right now. Thoughts floating in and out, some clear, some fading. A stream of ideas that feels private and personal. And then place that side by side with a night sky. Stars scattered across space. Galaxies clustered together. Faint clouds of light stretched across a dark background. At first glance, the mind and the sky couldn't seem further apart. One is a private mental landscape. The other is a vast physical reality outside of us. But the more we've studied the brain, and the more we've mapped the universe, the harder it has become to ignore that these two systems, as distant as they appear, echo each other in ways that are not only poetic but scientifically striking. Your brain contains about 86 billion neurons. Each one connects to thousands of others, forming a network of extraordinary complexity. The observable universe, in turn, holds something like 2 trillion galaxies, each containing hundreds of billions of stars. When scientists compared simulations of the cosmic web, the vast filament-like structure that links galaxies, with computer models of neural networks, the similarities startled them. Both systems grow into branching, interconnected webs. Both rely on nodes and connections that vary in strength. Both emerge out of simple ingredients that scale up into staggering complexity. Of course, the brain exists on a tiny scale compared to the cosmos, but the patterns that emerge look oddly familiar. But what does that really mean for you? Does it mean your thoughts are literally galaxies, or that your memories are constellations waiting to be traced? Not exactly. But it does suggest that your mind is not an isolated organ sealed off from reality. Instead, it is shaped by the same physical laws, built from the same atoms, and organised by the same kinds of principles that govern the largest structures in existence. When you notice that parallel, the idea of being connected to the universe stops being vague and begins to sound like a recognition of family resemblance. The mind and the cosmos are built by the same builder. Take the very matter of your brain itself. If you could peel back layers and look at the elements inside you, you'd find carbon, oxygen, hydrogen, nitrogen, calcium, phosphorus, elements that were forged in the cores of our ancient stars. Every atom heavier than hydrogen was cooked in nuclear fusion or scattered across space when stars exploded. That means your brain isn't just a metaphorical child of the universe, it's literally assembled from its remains. The calcium that helps neurons fire was once inside a star. The iron moving through your blood was created in a supernova. When you think, when you wonder about anything at all, you're using atoms that were shaped billions of years ago in cosmic furnaces, To say you're connected is to recognize that your very ability to have a thought is powered by ancient starlight trapped in matter. The way those atoms now behave also reveals another connection. Your brain communicates through electricity and chemistry. Tiny charged particles, mostly ions, move back and forth across membranes, creating pulses that travel along neurons. At the same time, chemical messengers called neurotransmitters leap across gaps between cells, carrying signals forward. These interactions are happening in the dark silence of your skull, yet they echo principles that operate everywhere in the universe. Electricity is not unique to your brain. It dances in storms on Jupiter, arcs in solar flares, and surges through galaxies in colossal currents. Chemical reactions are not unique to human thought. They build the atmospheres of planets, sculpt the chemistry of comets, and seed clouds with molecules that may one day become life. What feels like an inward, hidden process is actually a local expression of something universal. You can also think about rhythm. Your brain isn't constantly firing in chaos. It generates patterns, oscillations, rhythms of activity that shift with your state of being. Slow waves dominate deep sleep. Faster rhythms appear during focus. Your brain cycles, shifts, and pulses. At the same time, the Earth spins, the Moon orbits, planets revolve, and galaxies rotate. The universe itself is a grand clock of cycles and oscillations, from seconds to eons. Once again, the parallel isn't mystical, it's structural. Living matter has grown under these cycles, adapted to them, and now mirrors them. The rhythms inside you resonate with the rhythms outside. And yet, none of this means your brain is just a passive receiver, shaped only by cosmic forces. There's another possibility, one that scientists and philosophers still wrestle with. Maybe your awareness itself feeds back into the story of the universe. When you observe something, measure it, notice it, does that act play a role in shaping what is real? Physics has suggested that on the smallest scales, observation changes outcomes. That doesn't mean human consciousness controls the cosmos, but it does mean that the existence of an observer, the simple act of noticing, is not irrelevant to how reality unfolds. The brain then is not only connected to the universe by origin, matter, and structure, but also by participation. You, with your thoughts, are part of the ongoing experiment of existence. This might sound enormous, and it is. But remember, you don't need to hold the entire cosmos in your mind at once. It's enough to recognize that the small details of your life, breathing, blinking, thinking, are already cosmic activities. You're not separate. You never were. The border between self and universe isn't a wall. It's a thin, shifting edge, like the horizon. And while most of the time you go about your day without noticing, at night, when things are quiet and questions linger, you can feel that edge blur. So as you rest, as you let this question drift further in, you might picture your mind not as something sealed in a skull, but as a pattern of matter and energy folded into a larger pattern. The same kinds of connections that bind stars to galaxies bind neurons to networks. The same particles that hum in the cosmic background hum in your blood. The same light that left distant galaxies billions of years ago is striking your eyes right now, feeding signals into your brain that become this very image of the universe. The line between inner and outer becomes less sharp, more like a gradient, and in that recognition, the question of whether your brain is connected to the universe begins to feel less like a mystery and more like an ongoing fact of your existence. And this is only the beginning, because once you accept that your thoughts are built of stardust and electricity, you begin to wonder how deep the connections go. Do the shapes of your memories resemble the shapes of galaxies? Do the rhythms of your dreams echo cosmic cycles? Could your consciousness itself be a reflection of the universe becoming aware of itself? These are not quick questions with simple answers. They are long, winding paths we can follow gently, slowly, step by step, without ever needing to rush toward a conclusion. When you picture the universe, it's natural to imagine something vast and outward, galaxies expanding away from each other, stars burning through lifetimes that last billions of years, clusters of light stretching so far that even the speed of light takes ages to cross them. But what if we reverse the direction of imagination? Instead of looking outward, what happens when you look inward with the same kind of wonder? The folds of your brain, the layers of tissue, the electrical signals flowing through them, can seem at first glance like ordinary biology. Yet when you start to explore the scale and the organization, you realize you're carrying something astonishing inside your head. A structure so complex that in many ways it mirrors the very cosmos it tries to understand. Think for a moment about how much activity is happening inside your mind right now, even as you listen. Neurons are firing, releasing neurotransmitters, sending electrical impulses across intricate pathways. Some circuits are recalling memories, others are processing the meaning of these words, still others are managing your breathing and your heartbeat quietly in the background. All of this together creates the flow of awareness you experience. It may feel singular and simple, like one continuous stream, but beneath it lies a network that rivals the most elaborate systems in the universe. If you could shrink yourself down to the microscopic scale and wander through your brain, you would see a landscape unlike anything else. Neurons reaching out with long branching arms, connections called synapses forming bridges from one cell to another, millions of signals firing every second. It would look less like a machine and more like a galaxy of living stars, each one glowing and flickering with bursts of activity. The density of this network is staggering. In a single cubic millimeter of brain tissue, scientists estimate there can be up to 1 billion synaptic connections. That's just in a space smaller than a grain of sand. Multiply that across the entire brain, and you end up with a system that is so richly connected that it seems almost cosmic in scope. Now compare that with the way galaxies form structures in the universe. Galaxies themselves cluster together, drawn by gravity, forming groups, filaments, and vast voids. When astronomers simulate these structures and then set them side by side with computer models of neural networks, the similarities are uncanny. Both rely on nodes and connections, both form hubs where activity concentrates, both grow by linking smaller parts into larger wholes. The scales are unimaginably different. Your brain exists on the order of centimeters, the cosmic web spans billions of light years, but the shape of the network, the way complexity arises, seems to follow a kind of repeating pattern. That doesn't mean the brain and the cosmos are identical, but it does suggest that both are products of universal principles, systems that distribute energy, process information, and evolve over time tend to create networks. Whether those networks are made of neurons or galaxies doesn't matter. The pattern emerges because it is efficient, resilient, and capable of supporting complexity. In that sense, when you think about your brain as a universe within, you're not being metaphorical. You're recognizing that the same logic that sculpts the stars has also sculpted the folds of your own mind. Another way to see this is by considering scale. The universe holds an estimated 2 trillion galaxies. Your brain holds about 86 billion neurons. If you line those numbers up, the galaxies outnumber the neurons, but not by as much as you might expect when comparing a person's head to the entire cosmos. What's striking is not the raw numbers, but the way both systems seem to achieve richness by balancing vastness with connectivity. A galaxy is meaningful not just as a collection of stars, but as a participant in a larger cosmic structure. A neuron is meaningful not just as a single cell, but as part of the web of communication that generates thought. Both require networks to reveal their true nature. You might wonder what it means for your everyday life to think of the brain this way. On one level, it's a reminder of scale. When you're caught up in daily worries, it's easy to feel small, isolated, and separate. But consider that the complexity of your mind is, in a sense, a microcosm of the entire universe. The same way you look at the night sky and feel awe at its immensity, You can look inward and recognize that something just as staggering is happening beneath the surface of your thoughts. The neurons firing in your brain are participating in a dance of complexity that rivals anything unfolding across galaxies. That perspective can make your sense of self feel less like a tiny fragment and more like a continuation of the same cosmic story. Let's pause with an image. Imagine you are holding a clear glass sphere. Inside it, faint glowing lines stretch and connect, forming a delicate, shimmering web. This is your mind, alive with connections. Now imagine placing that sphere beside an image of the cosmic web, filaments of galaxies stretching across billions of light years. The resemblance is undeniable. One is small enough to rest in your hand, the other larger than anything we can imagine, yet both are bound by repeating principles of nature. This isn't just coincidence. It is a glimpse of how nature tends to build. The implications stretch further. The brain doesn't just resemble the universe in structure, it also reflects the universe in function. Galaxies are not static. They move, merge and evolve. Stars are born, live and die. Energy flows across space. In your brain, neurons are not static either. They form new connections, prune old ones, strengthen pathways with use, and weaken them without it. Thoughts, memories and skills shift, adapt, and transform. This constant flux mirrors the dynamism of the cosmos. Your brain is not a fixed organ delivering the same experience day after day. It is a living universe that is constantly reshaping itself, much as the cosmos reshapes itself on larger timescales. One of the most profound connections lies in the idea of emergence. In both brains and universes, simple rules give rise to complex outcomes. Neurons themselves don't think in isolation. Each one simply fires or doesn't fire, passes a signal or doesn't. Yet when billions of them interact, thought, memory and consciousness emerge. Galaxies themselves are just massive collections of stars, dust and gas. Yet when countless galaxies interact, cosmic webs and large-scale structures appear that are more than the sum of their parts. In both cases, complexity emerges not from the ingredients, but from the way the ingredients interact. This parallel suggests that your brain isn't just similar to the universe in appearance, but in the way it produces phenomena larger than itself. There's also the question of perspective. The universe is so vast that no single observer can take it all in. We rely on telescopes, maps, and models to stitch together an image of the whole. Likewise, you don't experience the individual activity of each neuron in your brain. Instead, you experience the larger emergent flow of awareness. Both the brain and the cosmos reveal themselves only at higher levels of organization, not in the smallest details, but in the way those details combine. When you consider these parallels, it becomes harder to treat your mind as separate from the universe. Instead, it feels like a fractal piece of it, a smaller echo of the larger design. That doesn't mean the brain controls the cosmos or vice versa. It means they are connected by the fact that both are born from the same laws, the same ingredients, and the same evolutionary tendencies toward complexity. Thinking of the brain as a universe within helps dissolve the line between inward and outward exploration. Studying your own mind is, in a very real sense, studying the cosmos on a smaller canvas. And perhaps most intriguing of all, your brain isn't just a miniature reflection of the universe. It is also the tool by which the universe becomes aware of itself. All the complexity, all the networks, all the patterns have created something capable of asking questions, forming models, and reflecting on its own origins. When you wonder about galaxies, it is neurons shaped by stardust that are doing the wondering. When you map the cosmic web, it is a smaller neural web that is interpreting the signals. Your mind doesn't just resemble the universe, it is the part of the universe that looks back, curious about where it came from. This realization can be strangely comforting. It means that when you look at the night sky and feel small, you can remind yourself that you're not outside of it, but inside of it. Your brain is not just contained within the cosmos. It is an expression of it, carrying its patterns, its matter, its history. In this sense, your thoughts are not isolated ripples in a private pond. They are part of a cosmic ocean, reflecting back the patterns of the whole. So, as you rest and think about the question of whether your brain is connected to the universe, remember that the answer is already in your biology. The folds of your mind, the signals flashing across neurons, the very elements making them up, all trace back to the same story as the stars above. You're not just in the universe, you're of the universe, and when you think, wonder, or dream, it is not an isolated act, it is the universe through you, turning its gaze inward. And with that recognition in place, we can begin to explore the even stranger details of this connection. Because once you see the brain as a universe within, it's only natural to ask how its networks resemble the grandest networks of all, and what that resemblance might mean for the way we understand both mind and cosmos. If you close your eyes for a moment and picture the inside of the brain, the image that comes to mind might be a tangle of branching cells, each with long arms reaching out, electricity flickering across tiny gaps, signals flowing through a dense forest of connections. Now place that mental picture alongside an image of the universe at the largest scales we can observe, the cosmic web stretched across billions of light years. Both look remarkably similar, like two sketches drawn with the same hand. One map is inside your skull, the other spans the heavens, yet their structures echo each other in ways that are difficult to ignore. Scientists have taken this comparison seriously. Astrophysicists and neuroscientists have placed side-by-side computer simulations of the cosmic web and high-resolution scans of neuronal networks. What they found was more than coincidence. Both systems show branching networks organized into clusters connected by filaments. In the brain, the clusters are groups of neurons. In the cosmos, they're galaxies bound together by gravity. In both, the connections are neither random nor perfectly uniform. They follow statistical rules that make them efficient, robust, and capable of transmitting information or energy across vast distances, whether those distances are microns or millions of light years. The resemblance becomes even more striking when you compare numbers. Your brain contains about 86 billion neurons. The observable universe contains roughly 2 trillion galaxies. Different magnitudes, but the principle is familiar. Immense numbers of nodes connected into networks, each node holding its own complex interior. A neuron is not just a simple point. It has dendrites, axons, receptors, and its own micro-level complexity. A galaxy is not just a bright dot. It holds billions of stars, planets, black holes, and clouds of gas. In both cases, the nodes are worlds in themselves, yet they are also part of something larger, linked into webs that give them context. Why should two systems so different in scale and function look alike? One reason is efficiency. Networks that balance connectivity and economy tend to converge on similar patterns. If you connect everything to everything, the system becomes chaotic and overloaded. If you connect too sparsely, the system becomes fragile and isolated. Somewhere in between lies a sweet spot, often called a small world network, where clusters are locally dense but globally connected through a few bridging pathways. The brain has evolved this structure because it allows fast, flexible communication while conserving energy. The universe seems to have grown into similar patterns because gravity pulls matter together, but expansion stretches it apart, leading to clusters linked by filaments. Different forces, same outcome. Another reason is emergence. Both brains and universes are not designed by an external engineer, but grow according to rules of physics and interaction. Neurons form connections based on chemical gradients, electrical activity, and experience. Galaxies form structures based on gravity, dark matter, and the dynamics of expansion. Each local interaction is simple. A neuron releases neurotransmitters when it fires. A galaxy tugs on its neighbours with gravity. Yet as billions of these simple interactions add up, large-scale patterns emerge. The repetition of these principles across scales is what makes the structures of neurons and galaxies resemble each other. This resemblance has fascinated philosophers as much as scientists. Some have suggested that the brain and the cosmos are mirrors of each other, each reflecting the other's organization. That might be stretching the parallel too far, but it is undeniable that both reveal nature's tendency to repeat itself. Patterns that work well in one context often appear in another, scaled up or down. Trees branch like rivers, lightning forks like blood vessels. Neurons and galaxies form networks that, despite being separated by unimaginable differences in size, look as if they belong to the same family of designs. But this is not only about appearance. The patterns serve functions. In the brain, network structure governs how information flows, how memories form, and how resilient thought is to disruption. In the universe, network structure governs how galaxies exchange matter, how they evolve, and how energy moves across the cosmos. Both systems rely on redundancy, hubs, and paths that ensure survival. Damage part of the brain, and other regions can sometimes adapt to take over. Remove a galaxy from the cosmic web, and the surrounding filaments still link others into a coherent whole. The resilience of both systems comes from their shared network-like design. It's also worth considering information. In the brain, neurons transmit electrical signals that carry information about the world, your body, and your inner thoughts. In the universe, galaxies do not carry information in the same sense, but the structure of the cosmic web encodes the history of cosmic evolution. The distribution of galaxies tells scientists about the density of dark matter, the rate of expansion, and the early conditions after the Big Bang. In both cases, patterns hold meaning. A scan of brain activity reveals what a person is seeing or feeling. A map of galaxies reveals what forces shape the cosmos. Both brains and universes are not just networks. They are records, memories written into structure. One of the most intriguing studies comparing these two systems looked at how energy is distributed. In the brain, energy use is concentrated in certain hubs, with signals passing efficiently through key nodes. In the cosmic web, matter and energy also concentrate in dense clusters, with filaments acting as highways that transport material across space. When scientists compared the scaling laws, the mathematical rules that describe how networks distribute energy and matter, they found surprising similarities. It was as if the same equations could almost describe both systems, just applied at radically different scales. Of course, it's important not to confuse analogy with identity. Neurons are living cells evolved through biology. Galaxies are massive assemblies of stars formed through physics. Their similarities arise because both are complex networks shaped by universal rules, not because one directly copies the other. Still, the fact that such similar patterns repeat across scales points to something profound about the way nature builds. The universe seems to favour certain shapes, certain organisations, repeating them wherever conditions allow. When you think about this personally, it can shift how you see yourself. You're not just a mind inside a body separate from the cosmos. You're carrying inside you a network that echoes the largest structures in existence. Your neurons fire in patterns that resemble the filaments of galaxies. The same natural laws that shape the heavens also shape your thoughts. That connection can make your everyday mental life feel less isolated. When you wrestle with a memory, solve a problem, or daydream, you are participating in a pattern that resonates with the very design of the universe. And the repetition of these patterns goes even deeper. The way neurons connect and galaxies cluster both follow fractal-like distributions. A fractal is a structure that repeats its shape across scales, so that the whole resembles the parts. Trees are fractal, coastlines are fractal, and in a sense both the brain and the cosmos display fractal tendencies too. Dense clusters connected by branching structures, repeating across levels. That repetition gives rise to efficiency, resilience, and beauty. When you look at the stars and when you think a thought, you're engaging with fractal echoes of the same universal logic. It's possible, too, that these repeating patterns make the brain particularly suited to understanding the universe. Because your mind is organised as a network that mirrors cosmic networks, it may have a natural affinity for grasping them. That doesn't mean your brain is designed to understand galaxies, but it does mean that when you build mental models of cosmic structures, you are using a system that already organises information in a similar way. The universe understanding itself through brains may not be a coincidence, but an outcome of shared structure. This idea brings us to something quietly profound. If patterns repeat across scales, then in studying one, you glimpse another. Neuroscientists examining networks of neurons are, in a way, studying principles that also govern galaxies. Astrophysicists mapping galaxies are, in a way, revealing rules that also shape brains. Two sciences, seemingly separate, converge on the same mathematical languages. That convergence itself is evidence of the deep connection between mind and cosmos. And so, when you reflect on whether your brain is connected to the universe, remember that the connection is not vague or mystical. It is visible in the patterns that repeat. Neurons firing in webs and galaxies clustering in filaments both testify to the same underlying logic. You're not just an observer of the universe, you're part of its repeating design, a living example of the patterns that stretch from the microscopic to the cosmic. If the brain and the universe both rely on patterns of connection, what does that mean for the rhythms that flow through them? Could the cycles of thought and memory resemble the cycles of stars and planets? And what might those parallels reveal about the way your inner life resonates with the outer cosmos? When scientists first began mapping the large-scale structure of the universe, the results were not what anyone expected. Galaxies did not scatter randomly through space like confetti. They gathered into groups and clusters, linked together by long filaments of matter stretching across millions of light years. Between these filaments lay enormous voids, regions of near emptiness, so vast that entire galaxies drifted alone inside them. Taken together, the filaments, clusters, and voids formed what came to be called the cosmic web. It was not a tidy grid or a uniform fog. It was a web-like network, intricate and sprawling, shaped by gravity and the mysterious presence of dark matter. When neuroscientists map the connections inside the brain, they find something remarkably similar. Neurons are not scattered randomly. They gather into clusters, groups of cells specialized for vision, memory, movement, or emotion. These clusters are linked by bundles of axons, long fibers that carry signals between distant regions. Between clusters lie gaps, spaces with fewer connections, yet even these play a role in shaping the flow of information. Taken together, the clusters, connections, and gaps form what is sometimes called the connectum, the complete map of the brain's network. Like the cosmic web, it is not a simple tangle. It is structured, modular, and efficient. When you put images of the cosmic web beside images of the brain's connectum, the resemblance is astonishing. Dense nodes linked by filaments, pathways stretching across space, patterns that repeat across scales. One is measured in microns, the other in millions of light years, yet their shapes mirror each other. Both are networks, and both grow not by design, but by natural processes that follow universal rules. The cosmic web began with the Big Bang, an almost uniform soup of matter and energy. Tiny fluctuations in density grew over time as gravity pulled matter together. Regions that were slightly denser attracted more matter, becoming denser still until galaxies formed. These galaxies gathered into clusters, and clusters connected into filaments, leaving behind vast voids. The process was gradual but inevitable. Guided by simple physical laws, the neural network began before birth, as neurons formed in the developing brain. At first, they reached out randomly, sending axons in many directions, but over time, connections were strengthened or weakened depending on activity. Neurons that fired together tended to connect more strongly, while unused connections were pruned away. This process created clusters of related functions, linked by long-distance pathways. Like the cosmic web, the brain's network grew not from a blueprint, but from local interactions guided by simple rules of use and efficiency. In both systems, the result is a network that balances local specialization with global integration. In the brain, local clusters handle specific tasks, vision, hearing, language, but these are connected by pathways that integrate information into unified experience. In the universe, clusters of galaxies form local communities, but filaments link them into the structure of the cosmos as a whole. Neither system is completely centralized nor completely scattered. Both exist in a balance that supports complexity and resilience. One of the most striking findings is that the brain and the cosmic web share similar ratios of matter to energy. Studies comparing the distribution of matter in the universe with the distribution of water and energy in the brain found that both systems allocate resources in similar proportions. In the universe, about 30% of matter clusters into filaments and nodes, while 70% is spread more diffusely as dark energy. In the brain, about 30% of water is stored inside cells, while 70% flows in the extracellular space. The numbers are not identical, but the parallel is striking. Both systems seem to divide resources between dense nodes of activity and diffuse backgrounds that support them. The similarity extends to dynamics. The brain is not static. Connections strengthen and weaken with use. New pathways form, old ones fade. Likewise, the cosmic web is not fixed. Filaments stretch as the universe expands, galaxies merge, drift, and change. Both systems are living in the sense that they evolve. They are networks that are constantly reshaping themselves over time, always in motion, always adapting. Another connection lies in the way both systems process information. In the brain, neurons communicate through spikes of electricity. Patterns of spikes form codes that represent sights, sounds, and thoughts. In the universe, galaxies do not fire spikes of electricity, but the cosmic web carries flows of gas, energy, and radiation. These flows shape the growth of galaxies and distribute material across the cosmos. In both systems, the network is not just structure, but function. The web is how things happen, whether those things are thoughts in a brain or galaxy formation in the universe. There is also the question of memory. In the brain, experiences leave traces in the form of strengthened or weakened synapses. The pattern of connections records the past, shaping how the brain responds in the future. In the universe, the distribution of galaxies also records history. The way filaments and voids are arranged preserves information about the early universe, the density of matter, and the role of dark energy. Just as neuroscientists can read memories in the brain's wiring, cosmologists can read the history of the cosmos in the shape of the cosmic web. Both systems are networks that remember. When you step back and reflect on this, it becomes clear why the comparison resonates so strongly. The brain and the universe are not just similar in appearance. They are similar in principles. Both grow through local interactions that build global patterns. Both balance density with diffusion. Both are resilient, dynamic, and capable of holding information about the past. Both are networks that make complexity possible. This does not mean the brain is literally the universe in miniature, but it does mean that the universe and the brain share a deep kinship in the way they are organized. That kinship is a reminder that your thoughts are not alien to the cosmos. They are another expression of its logic, unfolding at a smaller scale. When you think about the cosmic web, you are a neural web reflecting on a galactic one. The echo is real. This recognition can change the way you experience both your mind and the night sky. When you gaze upward and see the Milky Way, you can imagine it not just as distant stars but as part of a living network that resembles the one in your head. When you reflect inward, you can imagine your thoughts as part of a structure that echoes the design of galaxies. The border between inward and outward exploration becomes thinner. Studying the brain helps us understand networks. Studying the cosmos helps us understand networks. Together they point to principles that bind the small and the large into a shared framework. And there is something quietly profound about this symmetry. For billions of years, the cosmic web existed without awareness. Galaxies clustered and filaments stretched long before any brain ever formed. Then, on a small planet circling an ordinary star, a network of neurons grew that could wonder about the cosmic web. In that moment, the universe gained a way of seeing itself. The neural network became aware of the cosmic network, recognizing its own reflection at a grander scale. This doesn't make the brain cosmic in a mystical sense. It makes it cosmic in a practical one. Your mind is part of the same story as the stars, not separate from it. The patterns that govern galaxies also govern neurons. The cosmic web and the neural network are not identical, but they are kin. They are branches of the same family of patterns, repeating across scales, linking the inner and the outer, and so, as you settle into this idea, you can carry with you the image of two webs, one vast, one intimate, both humming with activity. One maps the universe, one maps your mind. Both are ways in which the cosmos organizes itself into complexity, and both remind you that to be human is not to stand outside the universe, but to live within it as a continuation of its repeating designs. If the brain and the universe share networks and webs, what about the ingredients themselves? What are the atoms that make up your brain, and where did they come from? And do those origins deepen the sense of connection between mind and cosmos? The thought that your brain resembles the cosmic web is striking on its own, but the connection between mind and universe runs even deeper than structure. It reaches down into the very matter that makes you up. Every cell in your body, every neuron that fires when you form a thought, every chemical that moves across a synapse is built from atoms that were born in stars. To understand your connection to the universe, you don't have to look only at patterns or at scale. You can look directly at the substance of yourself and trace it back billions of years to events that shaped the cosmos long before Earth even existed. The universe began with hydrogen and helium. Those were the lightest elements formed in the first minutes after the Big Bang. Everything else, carbon, oxygen, nitrogen, calcium, iron, came later, forged in the cores of stars through nuclear fusion. Stars are elemental factories. In their cores, hydrogen fuses into helium, helium into carbon, carbon into oxygen, and so on, building heavier and heavier elements as long as the star has fuel. When a massive star reaches the end of its life, it collapses and explodes in a supernova, scattering those elements across space. The debris from those explosions seeds clouds of gas, which later form new stars, planets, and eventually living beings. That means the calcium in your bones, the iron in your blood, the oxygen you breathe, and the carbon that forms the backbone of your DNA were all produced inside stars that lived and died billions of years ago. When Carl Sagan famously said that we are made of star stuff, it was not a poetic flourish, it was a scientific fact, and nowhere in your body is that fact more profound than in your brain. Your brain weighs about 3 pounds. Within those 3 pounds are billions of neurons and trillions of synapses. Each one is built from molecules, and those molecules are built from atoms that trace their origins to the stars. Carbon is the structural backbone of organic molecules, giving your brain cells their shape. Oxygen is critical for cellular respiration, the process that gives neurons the energy to fire. Nitrogen forms the basis of DNA, the code that builds your brain in the first place. Calcium flows in and out of neurons, triggering electrical signals. Iron moves through your blood, carrying oxygen to fuel your thoughts. Without these elements, there would be no neurons, no synapses, no awareness, and each of them was born in the violent, luminous heart of a star. Think about that for a moment. The same kind of star you see twinkling faintly in the night sky once burned brightly, lived its life and exploded, leaving behind the atoms that would one day assemble into you. Your thoughts tonight are powered by ancient starlight stored in matter. The electrical impulses flickering across your neurons depend on calcium ions that were once inside a star. The oxygen that fuels those impulses came from stellar fusion billions of years ago. You are, in the most literal sense, the universe reflecting on itself through recycled stardust. This recognition changes how you might view the boundary between self and cosmos. Often we imagine the universe as something out there, distant, separate, existing beyond us. But when you realize that the very matter of your brain is cosmic in origin, the line between out there and in here dissolves. You're not standing apart from the universe, looking at it from the outside. You're a small, temporary arrangement of its matter, animated by its energy, participating in its story. The story of how that matter gathered into your brain is long and intricate. After the first generation of stars exploded, their debris mixed with hydrogen and helium to form new clouds. Those clouds collapsed into new stars and planets, carrying heavier elements along with them. Over billions of years, cycles of starbirth and death enriched the cosmos with carbon, oxygen, nitrogen, and other ingredients of life. By the time our solar system formed about 4.6 billion years ago, the cloud of gas and dust from which it condensed was already rich with the products of earlier stars. Earth coalesced from that material, and with it came the elements that would form oceans, rocks, air, and eventually living cells. Life began simple, with molecules that could copy themselves. Over time, those molecules became cells, and those cells evolved into complex organisms. Neurons appeared as specialized cells that could send signals quickly. They organized into networks, and those networks eventually gave rise to brains. From starlight to neurons, the chain is unbroken. Every stage is part of the same cosmic process. The atoms inside your skull carry a history that stretches back almost to the beginning of time. Even today, your connection to the stars is ongoing. The oxygen you inhale with every breath was made in stars. The food you eat, built from carbon, nitrogen, and other elements, came from stellar origins. The iron in your blood cycles through you every moment, carrying oxygen to your brain, allowing you to think. Every heartbeat, every thought, every dream is powered by matter that once shone as light in the night sky. Some scientists point out that if you compare the elemental composition of the universe with the composition of the human body, the parallels are striking. The universe is about 74% hydrogen, 24% helium, and about 2% heavier elements. The human body is mostly oxygen, carbon, hydrogen, and nitrogen, with smaller amounts of calcium, phosphorus, and other elements. While the proportions differ, the overlap is remarkable. Both you and the universe are built from the same toolkit. The same set of elements that forms galaxies also forms you. Consider calcium again. In your body, it allows neurons to fire. In the cosmos, calcium lines are used by astronomers to study distant stars. The same element that lets you think is also the one that lets us detect the chemistry of galaxies billions of light years away. Or consider iron. In your blood, it binds oxygen. In the universe, it is produced in the core collapse of massive stars, marking the end of stellar life cycles. The same element that keeps you alive is also a marker of cosmic death and rebirth. Your life is written into the periodic table, which is itself a record of the stars. This idea has a way of shifting perspective. Daily concerns can feel pressing, even overwhelming. But when you pause and remember that your brain is built from the remnants of stars, it reframes those concerns. You're not small in the way you might think. You're the outcome of a process that spans billions of years and billions of light years. You are the cosmos in human form carrying within you the memory of stars. It also raises questions about consciousness. If the matter of the brain is stardust, then consciousness itself is a product of the universe. Awareness is not something outside of the cosmos, but something the cosmos does, given the right conditions. Just as stars burn, galaxies spin, and planets orbit, neurons fire and thoughts arise. In that sense, Your consciousness is as natural a phenomenon as gravity or light. It is the universe experiencing itself in a new way, not separate from it, but continuous with it. The idea that you are made of stardust is not only a scientific fact, but a grounding one. It connects you to everything around you. The same atoms in your brain are in the trees, the oceans, the air, and the stars above. You're not apart from nature. You are nature arranged into thought. And that thought in turn can reflect on its own origins, creating a loop in which the universe becomes self-aware through you. So when you ask whether your brain is connected to the universe, the answer is not only yes, but profoundly so. The connection is not metaphorical, it is material. The atoms of your skull, the ions firing across your synapses, the molecules coding your DNA, all come from the stars. Your brain is not just in the universe, it is of the universe, and when you think, you're using the very stuff of galaxies to wonder about galaxies, how those atoms behave once they are inside you. Matter alone does not explain thought. The calcium, carbon and iron may form the substance, but what about the activity? How does stardust come alive with electricity, light and rhythm? Inside your brain right now, a quiet conversation is taking place. It isn't spoken in words or written in symbols. It isn't even carried by sound. It is a language made of electricity and chemicals, pulses and patterns, an ongoing dialogue among billions of neurons. This conversation doesn't stop, not even when you sleep. It is the foundation of thought, memory, movement and awareness. And it is a language that links you back to the universe itself, because the signals that pass between your neurons are part of the same physical principles that move through stars, planets, and galaxies. Every thought you have is carried by electricity. When a neuron is activated, it sends an electrical impulse down its axon. This impulse is generated by the movement of charged particles, mainly sodium, potassium, and calcium ions, across the cell membrane. The result is a tiny spike of voltage called an action potential. That spike travels rapidly along the axon until it reaches the synapse, the gap between neurons. There, the signal is converted into a chemical message. Neurotransmitters are released, drift across the gap, and bind to receptors on the next neuron. The process is repeated endlessly, billions of times every second across the vast neural landscape inside your head. It's astonishing to realize that everything you experience, your memories, your sense of self, the sound of this voice, is being carried by electrical pulses that are no more than a few millivolts in size. They last only 1,000th of a second each. Yet by combining into patterns, they create thought and awareness. This is the language of the brain. Not words or pictures, but electrical signals organized in rhythms and codes. Now step back and think about electricity in the larger universe. Lightning crackles across the sky during a storm, a dramatic display of charge moving through air. On Jupiter, lightning bolts hundreds of times more powerful than those on Earth rip across the planet's atmosphere. Solar flares erupt from the sun, releasing immense bursts of charged particles into space. Magnetic fields guide streams of plasma through galaxies. Electricity is not a human invention. It is a natural phenomenon, written into the laws of physics, shaping the cosmos across scales. The tiny electrical pulses in your neurons are another expression of the same force that lights the heavens. Light, too, plays a central role in this conversation. Your brain is sensitive to light not only through your eyes, but through its rhythms. Photons, particles of light, enter your eyes and strike photoreceptor cells in the retina. Those cells convert light into electrical signals, which are carried into the brain along the optic nerve. The signals are processed through layers of neurons, eventually creating the images you see. Every sight you have is built from photons that travelled across space before landing in your eyes. Some of those photons were emitted by a lamp a few feet away. Others may have left the sun 8 minutes ago. Some could have crossed space for millions of years before reaching Earth as starlight. In every case, your brain turns light into information, folding the universe directly into your perception. But light does more than allow you to see. It also helps regulate your brain's rhythms. The cells in your brain follow a daily cycle, the circadian rhythm, which synchronizes with the rising and setting of the sun. Light entering your eyes resets this clock every day, keeping your internal rhythms aligned with Earth's rotation. Without light, the rhythm drifts. With light, it stays anchored. In this way, photons from the sun guide not only your vision, but your very sense of time, helping your brain align with the spinning of the planet. The language of electricity and light inside your brain is not random noise. It is structured, rhythmic, and meaningful. Neurons fire in patterns, oscillating together in waves. Some waves are slow, appearing during deep sleep. Others are faster, appearing during focus and problem solving. These brain waves coordinate activity across different regions, ensuring that signals arrive together and information is integrated. Without rhythms, the language of the brain would be chaotic. With rhythms, it becomes coherent, allowing billions of neurons to act in harmony. Similar rhythms appear in the cosmos. Stars pulse with regular patterns of brightness. Planets orbit their stars in steady cycles. Galaxies rotate over millions of years. The universe is full of oscillations, cycles of energy and light repeating over and over. Your brain's electrical rhythms echo these cosmic rhythms, scaled down but no less essential. The cycles that allow you to think and dream are part of the same logic that governs stars and galaxies. The idea that your brain speaks in the language of electricity and light connects you to the cosmos in yet another way. It means that your inner life is not some mysterious exception to the laws of physics. It is a continuation of them. The same principles that move charges through plasma clouds and guide photons across space are at work in your neurons. When you think, you are not defying physics, you're using it. Your electricity organized into thought, light organized into perception. Consider for a moment how delicate and efficient this system is. A single neuron firing produces a voltage change of only about 1/100th of a volt. Multiply that by billions, and your brain uses only about 20 watts of power, less than a dim light bulb. With that small amount of energy, it performs feats no supercomputer can match. It recognizes faces instantly, recalls memories from decades ago, imagines futures that have not yet happened, and generates the feeling of being alive. All of this on the energy it takes to power a small lamp. When you think about it this way, your brain is not only cosmic in origin, it is cosmic in efficiency, using minimal energy to achieve extraordinary complexity. There is another layer of connection here. Light doesn't only enter your brain through your eyes. The very atoms in your brain emit and absorb light. Every molecule can vibrate and rotate, releasing photons in the process. Scientists use techniques like functional near-infrared spectroscopy to study brain activity by shining light through the skull and measuring how it changes as neurons fire. The brain glows faintly, invisibly to the eye, but measurable to instruments. Your thoughts are literally accompanied by flickers of light, small echoes of the photons that travel across space. The link between electricity, light, and thought is not only scientific, but experiential. When you close your eyes and press gently on your eyelids, you may see patterns of light, phosphins, created by electrical activity in the retina. When you dream, your brain generates vivid images without any external photons, using only internal electrical patterns. When you remember something, neurons fire in ways that recreate patterns of past activity, a kind of inner light show of memory. In all of these cases, your brain is translating electricity into experience, showing you how deeply your awareness depends on these invisible signals. And so, when you ask whether your brain is connected to the universe, this is one of the clearest answers. Yes, because your brain speaks the same language as the cosmos. It uses electricity, which flows through stars and storms alike. It uses light, which crosses space to reveal galaxies. These are not human inventions. They are universal phenomena, woven into the fabric of reality. Your brain did not invent electricity and light. It grew out of them, harnessing them to create thought. This perspective can be grounding. It means that your mind is not floating apart from the universe in some mysterious isolation. It is rooted in the same principles that power the cosmos. The pulses in your neurons and the photons in your eyes are part of the same continuum as lightning, starlight, and cosmic radiation. You are participating in a universal dialogue, one that has been unfolding since the beginning of time. And from this recognition, more questions emerge. If your brain speaks through electricity and light, how do those rhythms connect with the larger rhythms of the universe? How does the daily cycle of the sun, the rotation of the earth, and the flow of cosmic energy shape the patterns of your thoughts and your sense of time? The electrical pulses and photons that make thought possible do not move randomly. They fall into rhythms, patterns that repeat, oscillations that synchronize. Your brain is not simply a storm of signals flashing in chaos. It is more like an orchestra with sections that come in and out, sometimes slow and deep, sometimes fast and sharp, sometimes layered into harmonies that allow experience to form. These rhythms are not metaphorical. They can be measured, recorded, and studied. Electroencephalograms capture the brain's waves, showing oscillations that rise and fall in different frequency ranges depending on whether you're awake, dreaming, or deeply asleep. When you're in deep, restorative sleep, slow delta waves dominate, rolling through your brain in a gentle rhythm of less than 4 cycles per second. When you're drowsy or relaxed but awake, theta waves rise, slightly faster, weaving into daydreams and drifting thoughts. When you're calm but alert, alpha waves appear, oscillating around 8 to 12 times per second, often linked with moments of focus or quiet meditation. Beta waves are faster, associated with active thought, problem solving, and concentration. And at the highest speeds, gamma waves emerge, often connected with perception, consciousness, and the integration of information across the brain. Each of these rhythms has a role, and together they give structure to the symphony of thought. These rhythms are not isolated to the brain. They are influenced by the rhythms of the body and the environment. The beating of your heart, the cycle of your breath, the daily rising and setting of the sun all feed into the patterns of neural activity. Your circadian rhythm, which governs sleep and wakefulness, is entrained by light from the outside world. The cycles of day and night synchronize the cycles of your brain. Even the lunar cycle, with its regular waxing and waning, has subtle effects on sleep in some people. You are not a closed system. Your brain's rhythms are tuned to the rhythm of nature. When you think about these cycles, it's natural to draw a parallel to the universe itself. Long before neuroscience, philosophers spoke of the music of the spheres, the idea that celestial bodies moved in harmonious patterns that could be imagined as music. Planets orbiting the sun, moons circling planets, stars rotating in galaxies, all of them follow cycles. The ancients imagined these cycles as notes in a cosmic song, inaudible but profound. Today we know that orbits are governed by gravity, not music, but the parallel remains. The universe, like the brain, is structured in rhythms. The Earth rotates once every 24 hours, giving us day and night. The Moon orbits Earth roughly every 29 days, giving us months and tides. Earth orbits the Sun once a year, giving us seasons. Galaxies rotate over hundreds of millions of years. Stars pulse in cycles, some swelling and shrinking rhythmically, their brightness rising and falling in patterns we can measure. Even the universe itself seems to have rhythms, with cosmic background radiation carrying faint oscillations from the earliest moments after the Big Bang. When you place these cosmic rhythms beside the rhythms of the brain, the resonance is clear. Both are systems that organize activity through cycles. Both depend on oscillations to create coherence. A neuron firing once means little, but billions of neurons oscillating together create patterns that carry thought. A planet orbiting a star is a single motion, but billions of stars moving together in cycles create galaxies. Scale is different, but the principle is shared. Cycles create structure, and structure creates meaning. What's striking is how much your brain depends on synchronization. Neurons in different regions must fire in time with each other to integrate information. If signals arrive out of sync, communication falters. Synchrony allows perception to unify. For example, when you see a face, different parts of your brain process shape, color, and movement. But because the neurons oscillate together in rhythm, the parts merge into a single coherent image. Rhythm is what binds separate processes into one experience. Without it, thought would fracture into isolated fragments. The universe, too, depends on synchrony. Planets stay in orbit because their rhythms of motion align with the pull of gravity. Binary stars orbit each other in repeating cycles. Galaxies spin in balance, their stars bound together in gravitational rhythms. Even at the largest scales, clusters of galaxies move in relation to one another in patterns that remain stable over billions of years. Without these cycles, the cosmos would dissolve into chaos. With them, it holds together. Rhythm, whether in neurons or in galaxies, is a principle of stability. There is also resilience in rhythm. The brain can adapt to disruptions in its cycles. Sleep may be lost one night, but the rhythm of circadian activity pulls it back the next. A region of the brain may be damaged, but other areas can sometimes synchronize to compensate. The universe shows similar resilience. A star may explode, but the orbiting planets find new paths. A galaxy may collide with another, but the larger rhythm of cosmic expansion continues. Rhythms bend, adapt, and absorb shocks, preserving the larger structure. What makes the parallel more than coincidence is that both brain rhythms and cosmic rhythms are governed by the same physical principles. Oscillations emerge whenever systems balance opposing forces. In the brain, ions move across membranes, pulled by voltage and chemical gradients. In the cosmos, planets move in orbits, pulled by gravity and inertia. In both cases, cycles arise from balance. The details differ, but the underlying logic is the same. Opposing forces produce oscillation, and oscillation produces rhythm. Thinking about this can change how you experience your own mind. Instead of seeing your thoughts as random, you can see them as part of an ongoing rhythm, one cycle feeding into another. Instead of seeing the universe as static, you can see it as a grand composition of cycles, some fast, some slow, all intertwined. You're living inside layers of rhythm, from the pulses of neurons to the rotation of galaxies, and your awareness, fragile and fleeting as it feels, is carried by these rhythms, stabilized by their patterns. It also suggests that your connection to the universe is not just structural or material, but temporal. You're not only made of stardust, you're made of cycles. Your sleep depends on the Earth's rotation. Your sense of time depends on the sun's light. Your brain's rhythms echo the rhythms of the cosmos. To be alive is to be synchronized with the universe, woven into its music. And just as music is more than individual notes, your life is more than individual moments. It is the rhythm that makes it coherent. You wake and sleep, inhale and exhale, focus and rest. These cycles define you as much as the elements in your cells, and they tie you to the larger cycles of planets and stars. You're not separate from the music of the spheres. You are part of it, playing your own rhythms within the cosmic composition. As you reflect on this, you might notice the subtle shift in how connected you feel. The rhythms inside your brain are not private, sealed off from the world. They are tuned to light, to gravity, to cycles larger than yourself. Every time you drift into sleep or wake to the morning sun, you are following cosmic rhythms. Every heartbeat and brainwave is a local variation on a universal theme. Your body does not live outside of time. It is guided by cycles tuned to the earth, calibrated to light and darkness. Deep within your brain, in a region no larger than a grain of rice, lies a small cluster of neurons known as the suprachiasmatic nucleus. This tiny structure serves as the master clock of your body. It sits just above where your optic nerves cross, perfectly positioned to receive information about light. When photons from the rising sun enter your eyes, they send signals directly to this clock, resetting it each day. This is how your brain stays in step with the rotation of the Earth. This clock doesn't just keep time for sleep and wakefulness. It coordinates nearly every system in your body. Hormones rise and fall according to its rhythm. Body temperature shifts through the day. Digestion, immune function, even the speed at which your brain processes information, all follow circadian cycles. Without this clock, the body would drift. With it, everything is synchronized, as if your physiology is a symphony and the suprachiasmatic nucleus is the conductor. The cycle it follows is close to 24 hours, but not exact. Left on its own, your internal rhythm runs slightly longer than a day, closer to 24.5 hours. That's why light is so crucial. Every morning, sunlight resets the clock, pulling it back into alignment with Earth's rotation. Without light cues, your rhythm would slowly drift out of sync. In experiments where people live in caves or rooms without windows, their sleep-wake cycles gradually shift until day and night lose their meaning. The circadian clock needs the Earth's turning to stay on course. This connection ties your brain directly to the planet. Every time you wake in the morning, it is because Earth has turned enough for sunlight to reach you. Every time you grow drowsy at night, it is because Earth has turned away, plunging your surroundings into darkness. Your sleep, your alertness, your energy levels are all linked to this planetary rhythm. You're synchronized not only with your own biology, but with the turning of the Earth itself. The influence of the circadian clock is profound. When it is disrupted, health suffers. Shift workers who stay awake at night and sleep during the day often experience fatigue, mood disturbances, and long-term risks to cardiovascular and metabolic health. Jet lag is another example. When you cross time zones, your internal clock is still set to the old rhythm, and it takes days to reset to the new one. These disruptions show how deeply your brain depends on alignment with Earth's rotation. It is not optional. It is essential. Light is the key signal, but it is not the only one. Temperature, social interaction, and even the timing of meals can shift the circadian rhythm. These cues, called Zeitgebers, help the brain stay coordinated with the outside world. Still, light is the strongest and most direct. Without it, the clock falters. With it, the clock remains steady. The simple act of sunlight falling on your eyes each morning links you to the sun, to Earth's spin, and to the cycle of day and night that has governed life for billions of years. It is remarkable to think that the same rotation of Earth that causes sunrise and sunset also guides the rhythm of your neurons. The turning of a planet, a cosmic event, is written into the firing of cells in your brain. This is not metaphor, but biology. The cycle of Earth's rotation has been encoded into the DNA of life, shaping every organism that has ever lived. Plants open and close their leaves according to light. Birds migrate according to seasonal cycles. And humans, with their complex brains, still rely on the same cues to rest and to wake. The circadian clock does more than regulate sleep. It also shapes how your brain processes information. Studies show that alertness, memory, and reaction time all follow daily patterns. In the morning, certain tasks may feel easier. In the evening, others may come more naturally. This ebb and flow is not about willpower. It is about biology, governed by rhythms that trace back to the spinning of the Earth. Even creativity seems to wax and wane according to circadian timing. Your ideas are not separate from the planet. They are scheduled by it. There is beauty in this connection. Imagine the Earth turning slowly beneath the stars, carrying you into light and then into darkness. That motion, steady and ancient, is not just something you observe, it is something you embody. Your brain is tuned to it. Your thoughts rise and fall with it, the spinning of a planet is written into your experience of time, awareness, and rest. The link goes deeper still. The circadian clock communicates with nearly every cell in your body. Even cells far from the brain contain their own molecular clocks, tiny oscillators that regulate activity. These peripheral clocks are synchronized by signals from the master clock, keeping the body aligned. But they too respond to light, temperature, and food. This means that your body is a collection of rhythms within rhythms, all coordinated by the brain, all tied to the cycle of Earth's turning. From an evolutionary perspective, this makes perfect sense. Life developed on a rotating planet. Organisms that could anticipate day and night had an advantage. They could prepare for light, conserve energy in darkness, and align their activity with predictable cycles. Over time, these rhythms became embedded in biology, passed down through genes, refined by adaptation. Your circadian clock is a legacy of billions of years of life learning to live with Earth's spin. This realization reshapes the way you think about being alive. You are not a static creature living against the backdrop of a rotating world. You're a rhythmic being synchronized to the planet. Your brain is not only influenced by the cosmos in abstract ways, it is directly tuned to Earth's rotation, resetting every morning as light enters your eyes. Your sense of time, your alertness, your need for sleep are all echoes of a planetary cycle that has been repeating since the planet formed. This is another way your brain is connected to the universe. Not only are you made of stardust and shaped by universal patterns, you're also timed by the turning of the Earth. The rhythm of a planet has become the rhythm of your thoughts. The cycle of a day has become the cycle of your awareness. You live inside time not as a detached observer but as a participant, your neurons ticking in rhythm with the world's rotation. If your brain is tuned to Earth's spin, how is it shaped by larger cycles, by the pull of the moon, by the orbit of the Earth around the Sun, by the slow turning of galaxies? Do these larger rhythms find their way into the rhythms of thought, dreams, and imagination? And if so, how deeply is the mind interwoven with the cosmos? When you fall asleep at night, your brain doesn't switch off. It enters another mode, one that is just as structured and active, though it feels very different from waking life. In this mode, your mind generates stories, images, and sensations that unfold without your conscious control. These are your dreams. They may seem random, surreal, or fleeting, yet they are the product of the same neurons and networks that manage memory, perception, and awareness during the day. Dreams are not just private hallucinations. They are evidence that the brain, even in rest, remains creative, exploratory, and deeply connected to the rhythms of the cosmos that shape its activity. Dreams are most vivid during rapid eye movement sleep, or REM sleep, a stage that occurs several times each night. During REM, your brain activity is almost as high as when you're awake. Neurons fire rapidly, the visual centers of the brain light up, and emotional areas such as the amygdala become highly active. Meanwhile, your body is paralyzed, preventing you from acting out the movements in your dream. This combination, an active brain in an immobile body, creates the conditions for vivid inner experiences. Why dreams occur is still debated. Some researchers believe they are a way of processing memories, integrating the events of the day into long-term storage. Others see them as a testing ground for problem solving, a mental space where the brain explores scenarios in preparation for real life. Still others think dreams may simply be the byproduct of neurons firing, with meaning added only afterward. Whatever their origin, they reveal that the brain does not rest quietly. It imagines, it rehearses, it constructs realities of its own, and those imagined realities often echo the cosmos. People dream of flying, of travelling through space, of seeing stars and strange worlds. Even without knowledge of astrophysics, the human brain seems drawn to cosmic imagery. This is not surprising. The brain evolved under the night sky. with stars as a constant presence. For tens of thousands of years, humans have looked upward and woven stories about the heavens. Those stories seep into imagination, appearing in myth, art, and dream. The cosmos has always been a canvas for the human mind, but there may be a deeper connection. Dreams often mirror the structure of the universe in subtle ways. Just as galaxies emerge from simple physical laws, dream narratives emerge from simple associations in memory. A sound from outside, a fragment of memory, a flash of emotion, all combine into a larger story. Dreams, like galaxies, are emergent phenomena, born from local interactions that produce global patterns. They are miniature universes built from the ingredients of thought. This connection grows clearer when you think about imagination more broadly. During the day, when you picture something that isn't in front of you, a landscape, a future plan, a memory, you are engaging the same networks that activate in dreams. Imagination is the waking counterpart of dreaming. It allows you to simulate realities, to test ideas, to envision possibilities, and often imagination stretches beyond the immediate, into the cosmic. You picture what lies beyond the horizon, what stars are made of, whether other worlds might hold life. The same brain that constructs dreams constructs the idea of the universe. There is a symmetry here. The brain is built from stardust, patterned like the cosmic web, tuned to the cycles of the Earth, and in return it imagines the stars. It reflects outward, constructing inner versions of the outer world. In doing so, it closes a loop. The cosmos shapes the brain, and the brain imagines the cosmos. Dreams are one of the clearest examples of this loop. They are private universes, temporary worlds that echo the larger universe outside. Scientists have even found that during dreaming, the brain's default mode network, an interconnected set of regions active during rest and self-reflection, plays a major role. This network is involved in imagining the future, recalling the past, and considering other perspectives. In dreams, it weaves together fragments into stories, often blending reality with fantasy. In this sense, dreams are not random. They are the brain's way of exploring possibilities, a rehearsal space for thought. And the possibilities they explore often stretch into cosmic imagery, because the brain is naturally curious about the vast and unknown. Some researchers suggest that dreams may even help foster creativity. Many scientific and artistic insights have reportedly emerged from dreams. The chemist Friedrich Kekulé claimed that the structure of the benzene molecule came to him in a dream of a snake biting its own tail. Paul McCartney has said that the melody for Yesterday came to him in a dream. These examples suggest that the dreaming brain is capable of making connections that waking thought sometimes misses. If imagination can reach cosmic scales in waking life, it is not surprising that dreams can reach into similar territory, pulling together distant associations into new patterns. When you dream of space, of stars, or of flying, you're not only echoing cultural stories, you're also expressing the brain's own affinity for vastness, pattern, and exploration. The same networks that map your environment during the day can be turned inward, generating inner environments at night. These inner landscapes sometimes resemble cosmic landscapes, not because the brain is trying to be symbolic, but because the same principles of pattern and scale apply. Dreams also raise the question of consciousness itself. In a dream, you can feel present, aware, even though your environment is generated internally. This shows how flexible awareness is, how it can adapt to different contexts. If your brain can create a convincing world inside itself, it suggests that consciousness is not tied only to external input. It is a state the brain can generate from within, using its own rhythms and signals. That flexibility may explain why humans can imagine the cosmos so vividly. If the brain can build entire dream worlds, it can certainly construct models of galaxies and space, even without direct experience. From another angle, dreams can be seen as a nightly reminder of your cosmic connection. They show that your brain does not need external light to generate brightness, does not need external landscapes to generate vastness. It can create its own inner stars, its own inner skies. The atoms in your brain, born in ancient stars, now reassemble into neurons that fire in rhythms to create dream universes. You are carrying the cosmos within you, not just in matter, but in imagination. And so, when you wake from a dream of flying through space, it is not only fantasy, it is a reflection of your connection to the universe. Your brain, built from stardust and patterned like galaxies, imagines stars because they are part of its origin. Dreams and imagination are not distractions from reality. They are extensions of it, inner echoes of outer truths. If your brain can create entire inner universes, what does that say about the connection between thought and reality? Are your dreams simply private fictions, or are they another way the universe explores itself? And how might these inner universes connect with the larger patterns of gravity, energy, and memory that govern the cosmos outside? When you think about gravity, the image that often comes to mind is of planets circling stars or apples falling to the ground. Gravity is the universal force of attraction, pulling masses toward one another, shaping the orbits of planets, binding galaxies into clusters, and curving the very fabric of space and time. It is steady, invisible, and constant. But if you step back and consider the way people interact, the way ideas spread and draw us together, there is a surprising parallel. Thoughts, like masses, seem to exert a kind of pull. Some ideas attract others, some draw communities around them, some grow stronger by pulling more minds into orbit. Just as gravity sculpts the cosmos, ideas shape human networks, pulling us into patterns of connection that mirror the universe itself. Your brain is full of ideas, memories, and beliefs, and none of them exist in isolation. Each thought is linked to others through associations. Think of the word ocean, and your mind might leap to waves, or beach, or blue. Those associations form a network, a web of meaning. When a new thought appears, it is pulled toward related ones, anchored by the gravity of memory. This is not physical gravity, of course, but the logic is similar. Thoughts attract other thoughts, clustering into constellations of meaning. And just as galaxies form from the pull of matter, your identity forms from the pull of ideas clustering together inside your mind. But the pull of ideas doesn't stop inside one brain. It extends outward, linking people. When one person shares an idea, it can spark recognition in another, pulling them closer. Communities form around shared beliefs, shared visions, shared questions. Throughout history, entire civilizations have been shaped by the gravity of ideas. Religion, philosophy, science, art. Each began as a spark in a few minds but grew into vast networks that drew millions into their orbit. The Renaissance, for example, was not just a period of art and discovery. It was a gravitational event of ideas, pulling Europe into new ways of thinking. The Enlightenment spread through pamphlets, letters, and conversations, its pull reaching across continents. In our time, ideas travel through the internet at light speed, attracting global communities in moments. The force may not be measurable in newtons, but its effect is as real as the pull of gravity on planets. On a smaller scale, you can see this in your daily life. When someone you trust shares an idea, you feel its pull more strongly. The closer the relationship, the greater the gravitational effect. Just as gravity is stronger when objects are closer together, ideas spread more easily among people who are already connected. That is why conversations with friends, family, and colleagues often carry more influence than distant broadcasts. Proximity strengthens pull, both in physics and in thought. And just as massive objects bend space around them, massive ideas bend the landscape of thought. When Einstein introduced the theory of relativity, it reshaped physics, curving the trajectory of future research around it. When Darwin proposed evolution by natural selection, it redefined biology, pulling countless discoveries into its framework. These ideas were so massive in intellectual weight that they permanently altered the space of human understanding. They didn't erase smaller ideas, but they bent them, changing their paths. Just as planets orbit stars, smaller ideas orbit larger ones, shaped by their gravitational field. The parallel grows stronger when you consider how fragile and resilient these systems are. Gravity holds planets in orbit, but small disturbances can shift their paths. Likewise, communities held together by shared ideas can be disrupted by new information, conflict, or change. Yet gravity also provides stability. Earth orbits the Sun year after year, stable enough for life to flourish. Communities of thought too can remain stable for centuries, sustained by the steady pull of shared beliefs. The balance between change and stability is what makes both systems dynamic rather than static. Neuroscience adds another layer. Inside your brain, when neurons fire together repeatedly, their connections strengthen. This principle, often summarized as cells that fire together wire together, is a form of attraction. Neurons that are active at the same time become more likely to influence each other in the future. Over time, patterns of thought become grooves, pathways along which new thoughts are pulled. This is why habits form, why biases persist, and why learning creates lasting changes. Thought has its own gravity, shaping the flow of future thought. The cosmos itself shows a similar memory. Once a galaxy forms under gravity, it tends to hold its shape for billions of years. Its pull defines its future. Once a black hole forms, its gravity is so intense that nothing escapes, not even light. These cosmic structures are extreme examples of attraction and memory, showing how powerful gravity can be in shaping destiny. In a smaller but parallel way, strong ideas hold human thought, anchoring generations. They can be difficult to escape, just as black holes trap matter. Some ideas liberate, others confine, but all exert influence. It is fascinating to think that gravity, which binds stars and galaxies, and the attraction of ideas, which binds minds and societies, share such striking parallels. Both are invisible forces. Both create networks of orbiting participants. Both balance change with stability. Both allow complexity to arise from simple rules, and both remind us that connection, whether physical or mental, is a fundamental feature of the universe. From a personal perspective, recognizing the gravity of thoughts can change how you see your relationships. When you share an idea, you're not just communicating. You're exerting a pull, however small, on another person's mind. When you listen, you're allowing their gravity to influence you. Every conversation is an exchange of orbits, small adjustments to the trajectories of thought. Over time, these pulls accumulate, shaping who you are. Your beliefs, your worldview, even your sense of self are not isolated. They are the result of countless gravitational interactions with others. This is why humans are social creatures. We are not designed to think in isolation. Our brains evolved to share ideas, to synchronize with others, to form communities of thought. Just as stars cluster into galaxies rather than drifting alone, people cluster into societies rather than living in solitude. The gravity of ideas makes this inevitable. We are pulled together, not only by need or survival, but by the attraction of shared meaning, and the parallel extends still further. In physics, gravity is universal. It acts on all masses, no matter how small or large. In human life, the gravity of thoughts is also universal. Even a small idea shared at the right time can spread far beyond its origin. A phrase, a symbol, a discovery, these can ripple outward, pulling millions into their orbit. Think of how simple words like freedom, justice, or love have shaped history. Their gravitational pull has been enormous, bending the paths of nations and individuals alike. The connection between gravity and thought reveals yet another way your brain is linked to the universe. The same laws that pull planets into orbit seem mirrored in the way ideas pull minds together. You're not separate from this. Every thought you have participates in this gravitational dance. Every conversation you engage in alters orbits, however slightly. Your inner life is not sealed away. It is connected, shaped by pulls that echo the cosmos. If gravity binds the cosmos and ideas bind humanity, what about the smallest scales? What about the flickering quantum fluctuations that shape both matter and awareness? Could the tiniest vibrations in the universe be linked to the flickers of consciousness in the brain? If so, the connection between mind and cosmos may reach even deeper than gravity, into the quantum fabric of reality itself. When you think of the universe, it is easy to picture vastness. Stars, galaxies, and clusters stretching across billions of light years, connected by threads of gravity, shaped by cosmic expansion. Yet beneath all of that immensity lies another world, one so small that it resists ordinary understanding. This is the quantum world, where particles flicker in and out of existence, where uncertainty reigns, and where the act of observation itself seems to play a role in shaping outcomes. For decades, physicists have explored this realm, and what they have found has startled not only science but philosophy. And as strange as it seems, some of the principles of quantum reality may also touch upon the mysteries of awareness inside your own brain. At its heart, quantum physics describes the behavior of the smallest building blocks of nature: electrons, photons, quarks, and other fundamental particles. Unlike the predictable paths of planets or the steady pull of gravity, these particles behave in ways that defy classical logic. An electron can act like a particle in one experiment and like a wave in another. A photon can travel multiple paths at once until it is measured. A particle's position cannot be known with certainty, only with probability. These are not illusions. They are the rules of reality at the smallest scales. One of the most mysterious features of this world is fluctuation. Even in a perfect vacuum, space is never truly empty. Particles continually appear and disappear, flickering into existence for a brief instant before vanishing again. This seething background, called quantum foam, fills every point of the universe. It is the foundation upon which all matter and energy rest. Without these fluctuations, atoms would not exist, stars would not burn, and galaxies would not form. The universe is built on restless motion at the smallest scales. Now think of awareness. Your mind does not flow as a single uninterrupted stream. It flickers too. Attention drifts in and out. Thoughts emerge and vanish. Neurons fire in spikes that last milliseconds. Consciousness, when studied carefully, shows rhythms and gaps. Just as the quantum world is not continuous but probabilistic, awareness is not perfectly smooth, but made of moments that weave together into a sense of continuity. Some neuroscientists argue that consciousness itself may be discrete, arising in bursts tied to brain rhythms. What feels like seamless thought may actually be constructed from countless flickers of neural activity, stitched together by memory. This parallel has led some thinkers to wonder whether the two worlds are related. Could the flickers of awareness in the brain be connected in some way to the fluctuations of the quantum world? This is a controversial question, and science has not yet given a definitive answer. Many neuroscientists argue that the brain operates at a scale too large and warm for delicate quantum effects to survive. They suggest that neurons obey classical physics, not quantum physics, and that consciousness emerges from networks, not particles. But others believe that quantum processes may play a role, especially in the microscopic structures of neurons. One of the most debated proposals comes from physicist Roger Penrose and anesthesiologist Stuart Hemmerhoff. They suggest that microtubules, tiny scaffolding structures inside neurons, may support quantum processes that contribute to consciousness. Their theory, called orchestrated objective reduction, claims that quantum fluctuations inside microtubules collapse into definite states, and that these collapses form the basis of conscious moments. The idea is bold and far from proven, but it reflects the possibility that awareness and quantum reality may be more entwined than we realize. Even if this theory does not hold, the parallels remain striking. Quantum physics shows us that the universe is not deterministic in the way classical physics once imagined. At its foundation, reality is built on uncertainty, probability, and flicker. Consciousness too is not fixed. It shifts, it wavers, it arises in moments of focus and fades in moments of distraction. Both reality and awareness are not rigid but fluid, made of fluctuations that give rise to patterns. Consider also the role of observation. In the famous double-slit experiment, particles behave differently depending on whether they are measured. When unobserved, they spread out like waves. When observed, they collapse into definite particles. The act of measuring changes the outcome. What this means has been debated endlessly, but one implication is clear. Observers are not irrelevant. They are woven into the fabric of quantum reality. Without observation, the universe behaves differently. Awareness, too, plays this role at another scale. When you turn your attention to something, you change it. Not physically, perhaps, but experientially. The act of noticing alters memory, strengthens connections between neurons, and changes what will be recalled later. Observation is not passive. It is active, reshaping both experience and brain. The parallel to quantum measurement is not exact, but it is suggestive. In both cases, observation is not an afterthought. It is part of how reality unfolds. This raises a profound possibility. If the universe at its foundation is probabilistic, and if awareness itself is built from flickering probabilities in neural activity, then perhaps mind and cosmos share a deeper kinship than we typically assume. Both are processes, not fixed things. Both are patterns of fluctuation. Both depend on observation to stabilize, and both remind us that what feels solid and certain is built from uncertainty underneath. From a practical perspective, recognizing this connection can change how you see yourself. You're not a static being, unchanging and rigid. You're a process of flickering signals, always in motion, always rebuilding. Your thoughts today are not the same as yesterday. Your awareness shifts moment by moment, and yet from this constant fluctuation arises the stable sense of self. Just as galaxies emerge from quantum foam, your identity emerges from neural flickers. Stability is built on motion. Certainty is built on uncertainty. And at the cosmic level, quantum fluctuations are not trivial. They seeded the universe itself. In the earliest moments after the Big Bang, tiny fluctuations in density were stretched by cosmic inflation into large-scale structures. Those tiny variations became the seeds of galaxies, stars, and planets. In a very real sense, everything we see today, the Milky Way, Earth, you, arose from random quantum jitters at the beginning of time. Without them, the universe would be uniform and lifeless. The cosmos itself exists because of fluctuations. If you connect this back to awareness, the symmetry deepens. Your thoughts too emerge from fluctuations. Random spikes of neural activity can trigger associations leading to new ideas. Creativity often begins with unexpected connections, small flickers of thought that grow into larger patterns. Just as the universe emerged from quantum fluctuations, imagination emerges from neural fluctuations. Both remind us that randomness is not the opposite of order. It is the seed of it. Some may find this unsettling. If everything is built on uncertainty, does that mean nothing is real? But uncertainty is not emptiness. It is possibility. The quantum world allows for countless potential states, and from them, reality crystallizes. In the same way, your mind allows countless potential thoughts, and from them, awareness crystallizes. What you are is not fixed. It is a process of choosing, of collapsing possibilities into moments of experience. The connection between quantum fluctuations and awareness does not mean consciousness controls reality, or that thoughts create the universe in a literal sense. But it does mean that the same principles of fluctuation, uncertainty, and emergence govern both. You're not separate from the quantum world. You're one of its outcomes, flickering into awareness just as particles flicker into existence. This perspective adds another layer to the question of whether your brain is connected to the universe. Not only is it built from stardust, not only does it echo cosmic webs and rhythms, not only does it follow the spin of Earth, it also shares in the most fundamental principle of reality, fluctuation. Your awareness is as restless and dynamic as the quantum foam. Your thoughts are as fleeting and powerful as the first ripples of creation. If both the universe and the brain are built on fluctuation, what role does order play? How do patterns emerge from chaos? How do memories persist in a world of constant change? When physicists describe the universe, one of the most fundamental concepts they use is entropy. At its simplest, entropy is a measure of disorder, of how energy and matter are distributed, of how many possible arrangements a system can take. Left on its own, any system tends to move toward higher entropy, toward more disorder, because disorder is simply more likely than order. A tidy room has only a few possible arrangements. A messy one has almost infinite possibilities. The same principle applies to the cosmos. The arrow of time is marked by the increase of entropy, guiding the universe from order toward disorder, from simplicity toward complexity, from stars burning brightly toward stars fading into darkness. But entropy is not only about decay or decline, it is also about memory, about structure, about the way information is preserved or lost. And when you consider your own brain, it becomes clear that entropy plays as much a role in your thoughts as it does in galaxies. Your awareness exists in the tension between order and disorder, between patterns and randomness, between memory preserved and memory lost. In this balance lies the connection between mind and cosmos. Consider the early universe. Just after the Big Bang, it was remarkably uniform, with matter and energy spread almost evenly across space. The entropy was relatively low, because there were few variations, but tiny fluctuations seeded by quantum jitters created small differences in density. Gravity amplified those differences, pulling matter together into clumps that became stars, galaxies, and planets. Out of low entropy and fluctuation came structure. The universe grew more complex even as its overall entropy increased, because complexity can arise as systems seek equilibrium. Stars formed, burned, and spread heavier elements into space. Galaxies collided, merged, and evolved. The order we see today, the beauty of the night sky, the architecture of galaxies, is the product of entropy at work. Now look inward. Your brain, too, begins with fluctuations. Neurons fire in patterns that are partly predictable and partly random. Out of this activity emerges thought. But thought requires order. Neurons must fire in synchrony to create coherent awareness. Memory requires stability. Synapses must strengthen to preserve information. And yet the system cannot be perfectly ordered. Too much rigidity would prevent learning, creativity, or adaptation. The brain thrives in the balance between order and disorder, between entropy rising and patterns forming. When you remember something, you are working against entropy. The natural tendency of matter is to disperse, for patterns to break down. But the brain resists this by strengthening synapses, carving paths that hold information. Still, memory is never permanent. Over time, traces fade, details blur, events are lost. Entropy asserts itself, slowly dismantling the order of memory. Forgetting is not a flaw. It is the natural outcome of living in a universe where disorder grows. This does not mean memory is futile, quite the opposite. The fact that memory persists at all is remarkable. It shows that life has found ways to resist entropy, to build local pockets of order in a universe that trends toward disorder. Every time you learn something, you create order out of fluctuation. Every time you recall a moment, you reassemble patterns that entropy would otherwise erase. Your mind is a small defiance of the cosmic trend, a pocket of resistance that holds on to meaning even as the universe moves toward greater disorder. The parallel to the cosmos is striking. Stars, too, are local resistances to entropy. They take hydrogen and fuse it into heavier elements, releasing energy and creating structure. They burn for billions of years, but eventually their fuel runs out and entropy wins. Galaxies too evolve, holding structure for billions of years but slowly dissipating. Black holes store information on their surfaces, but even they evaporate over unimaginable timescales. The cosmos, like the brain, creates order locally, temporarily, before entropy reclaims it. Both are processes of emergence and dissolution, of memory and forgetting. Entropy also explains why time flows the way it does. We remember the past but not the future, because entropy increases forward in time. Memory is possible because the past had lower entropy. Events left traces that persist. The future, not yet realized, has no such traces. This is why you can recall yesterday but not tomorrow. Your awareness rides the arrow of time defined by entropy. In this sense, memory itself is a product of cosmic law. The same principle that governs stars fading governs your ability to remember your childhood. Some neuroscientists describe the brain as an information processing machine, and in that framework, entropy is a measure of uncertainty. A highly ordered brain state has little entropy. A highly disordered one has much. Healthy consciousness seems to exist between the two extremes. Too much order, and the brain is rigid, stuck in repetitive patterns. Too much disorder, and it becomes chaotic, incoherent. Awareness thrives in the middle, where entropy is balanced, allowing flexibility, creativity, and stability at once. The universe follows a similar pattern. Too much order, perfect uniformity after the Big Bang, and nothing interesting happens. Too much disorder, complete thermal equilibrium in the distant future, and nothing interesting happens. Complexity arises in between, when matter clumps but not too tightly, when energy flows but not too chaotically. Stars form, galaxies swirl, planets orbit. Life emerges, consciousness thinks. Order and disorder intertwine, creating the richness we experience. Think about your daily life in this light. When you learn something new, you impose order on your neural networks. You strengthen connections, creating structure. When you sleep, some of those connections are pruned, entropy reclaiming what is unnecessary. The balance allows your brain to remain efficient. If you tried to keep every detail forever, your mind would collapse under the weight of information. Forgetting is as important as remembering. Disorder is as important as order. Entropy is not only decay, it is also the space in which meaning forms. This is why memory feels fragile. It is built against the current of the universe. Every recollection you hold is a structure maintained in a sea of entropy. You forget names, lose details, recall moments imperfectly, not because your brain fails, but because it is a small island of order in a vast ocean of disorder. And yet, for as long as it lasts, it is real, powerful, and deeply human. The link between entropy and awareness also helps explain creativity. When the brain is too ordered, it becomes stuck. When it is too disordered, it becomes incoherent. But in the balance, entropy allows ideas to combine in unexpected ways. Fluctuations in thought spark new connections. Randomness feeds innovation. In this sense, entropy is not the enemy of meaning. It is the source of it. Without randomness, thought would be predictable and dull. With it, thought becomes alive, surprising, and full of potential. The cosmos itself tells the same story. Without fluctuations, there would be no galaxies, no stars, no planets. Without entropy increasing, there would be no arrow of time, no evolution, no history. Complexity arises not in spite of disorder, but because of it. The universe is creative because it is entropic, and the mind is creative for the same reason. Reflecting on this connection can shift how you see yourself. You're not separate from the cosmic process. You're an expression of it. Your memories are temporary constellations in the sky of your mind, slowly fading but meaningful while they shine. Your creativity is a spark born from entropy, just as stars are born from collapsing clouds of gas. Your life is an interplay of order and disorder, of meaning formed against the flow of time, and just as the universe continues to evolve, so does your awareness. Memory is lost, but new memory is made. Entropy increases, but local order persists. The process never stops, because both brain and cosmos are not static but dynamic, always balancing order and disorder. If entropy shapes both the cosmos and the mind, what about the things we cannot see? The universe is held together not only by visible matter, but by dark matter, an invisible presence that shapes galaxies. Could the mind, too, be shaped by unseen forces, hidden processes that we cannot directly measure but that influence thought, emotion, and awareness? When astronomers study the universe, they see galaxies spinning, stars orbiting, clusters holding together, yet the motion doesn't quite add up. The gravity of visible matter, the stars, the gas, the dust, simply isn't enough to explain the observed movements. Something else must be there, unseen, exerting its pull. This is dark matter. It makes up about 85% of the matter in the universe, yet it cannot be seen directly. It does not emit or absorb light. It reveals itself only through its gravitational effects, shaping galaxies and anchoring cosmic structure. Without it, the universe as we know it would not hold together. Now think about your mind. Much of what shapes your thoughts, feelings, and decisions is also hidden from direct awareness. Psychologists call it the unconscious. These are memories you don't recall but that still influence you, biases you don't notice but that steer your choices, emotions that simmer beneath the surface, guiding your actions in ways you may only realize afterward. Like dark matter, the unconscious cannot be seen directly. You cannot point to it or measure it with ordinary perception, but its effects are unmistakable. It shapes the structure of your awareness, holding your inner universe together in ways you may not fully grasp. The parallel is striking. Just as galaxies would fly apart without dark matter, your conscious mind would lack coherence without the hidden processes that guide it. Your decisions are rarely the result of conscious thought alone. Studies show that much of what you do is initiated unconsciously, with awareness catching up only after the fact. When you reach for a glass of water, your brain has already prepared the movement before you feel the intention. When you choose between options, subtle biases have already tilted the balance before you reason through it. Consciousness is just the visible layer. Beneath it lies a vast unseen domain, exerting its quiet influence. In both cases, the hidden is greater than the visible. The stars, planets, and galaxies that shine are only a fraction of what exists. The conscious thoughts you notice are only a fraction of what your brain is doing. Beneath the glow of awareness lies a dark foundation, immense and essential. Without it, there would be no stability. Without it, there would be no structure. Consider memory. You can recall only a small portion of what you have experienced. Yet your brain stores far more than you realize, shaping perception and reaction unconsciously. A smell might trigger unease without you recalling why. A face might seem trustworthy because it resembles someone from your past, though you don't consciously notice the similarity. The unconscious is like dark matter in this way, hidden, silent, but powerful in its pull. The cosmos teaches us humility about what we cannot see. For centuries, astronomers assumed the visible stars told the whole story. Only in the 20th century did they realize that most of the mass of the universe is invisible. The mind teaches the same lesson. For centuries, philosophers assumed consciousness was the whole of the self. Only in recent decades have neuroscience and psychology revealed the depth of unconscious processes. In both cases, the hidden majority shapes the visible minority. And just as dark matter remains mysterious, the unconscious is still not fully understood. We know it exists. We know it exerts influence. But its exact nature remains elusive. Is the unconscious a storehouse of repressed memories, as Freud once thought? Is it a set of automatic processes optimized by evolution, as modern neuroscience suggests? Is it something even deeper, a hidden architecture of thought we have not yet mapped? These questions mirror those in cosmology. What is dark matter made of? Weakly interacting particles? Something beyond the standard model of physics? Or is it a sign that our understanding of gravity itself is incomplete? In both domains, the unknown shapes everything we see, reminding us how much lies beyond our grasp. This recognition changes the way you experience yourself. You're not fully transparent to yourself. You do not always know why you feel a certain way, why you choose as you do, why a memory resurfaces. These mysteries are not flaws. They are features of being human, expressions of the hidden structures beneath awareness. In the same way, galaxies are not transparent. Their shining stars conceal vast halos of dark matter that give them shape. Both outer cosmos and inner mind are built on unseen foundations. The parallel extends further. Dark matter does not cluster randomly. It forms halos around galaxies shaping the cosmic web. In the brain, unconscious processes also form structure. Habits, instincts, and emotional associations act as frameworks that guide conscious thought. Just as galaxies move within the gravitational field of dark matter, conscious thoughts move within the field of unconscious influence. You may feel free, but your freedom is shaped by hidden pulls. Recognizing this does not diminish choice. It deepens understanding. There is also resilience in the hidden. Dark matter stabilizes galaxies, making them resistant to disruption. The unconscious stabilizes behavior, providing consistency even when conscious attention wavers. You can walk without thinking about each step because unconscious processes handle it. You can speak fluently without planning every word because hidden networks manage the flow. Consciousness is a spotlight, narrow and focused. The unconscious is the stage, broad and sustaining. Without the stage, the spotlight would shine on nothing. This perspective can be both humbling and comforting. Humbling, because it reveals how much of you lies beyond awareness. Comforting, because it shows that you're supported by unseen processes that keep you steady. Just as the cosmos is held together by invisible matter, you are held together by invisible mind. The hidden is not something to fear. It is something to acknowledge, respect, and explore. And there may be another layer of connection. Some physicists speculate that dark matter may interact with ordinary matter in subtle ways we have not yet detected. Similarly, the unconscious may communicate with consciousness in subtle ways, through dreams, slips of the tongue, intuitions, or sudden insights. Both domains may hold mysteries that hint at deeper unity, connections not yet fully mapped. Recognizing this parallel also shifts how you see the boundary between self and universe. Both contain more hidden than visible. Both depend on the unseen to make the seen possible. Both remind you that mystery is not outside of you but inside you as well. The cosmos is not just vast and unknown. You are vast and unknown to yourself. Exploring either requires patience, humility, and curiosity. If hidden matter shapes galaxies and hidden processes shape the mind, what about hidden timing? Are there patterns in the way coincidences occur, in the way events align, in the way thoughts and moments seem to converge? Could there be synchronicities, subtle harmonies between inner and outer worlds that reveal another layer of connection between mind and cosmos? Every life contains moments that feel uncanny. You think of a friend you haven't spoken to in years, and a message from them appears the same day. You stumble across a book that speaks directly to a problem you've been wrestling with in silence. A song begins to play at the exact moment its lyrics answer the thought in your mind. Rationally, you know coincidences happen, and probability alone ensures that some will feel meaningful. But the experience of these moments can still feel larger than chance, as though there is a hidden rhythm connecting the inner and the outer. Psychologist Carl Jung gave this idea a name: synchronicity. He described it as meaningful coincidence, the alignment of events in a way that feels purposeful, even without a clear causal link. The cosmos itself is full of rhythms and alignments. The Earth spins, the Moon orbits, planets trace paths around the Sun. Eclipses occur when alignments coincide in just the right way. Seasons shift with cosmic timing. These patterns are predictable, yet when you notice them in daily life, they can still feel profound. To stand in the shadow of an eclipse, to see day turn to night in the middle of the afternoon, is to witness cosmic coincidence, celestial bodies aligning in a way that resonates with human experience. The rhythm of the universe becomes visible, reminding you that your life unfolds within larger cycles. Synchronicity, in the human sense, is less predictable. It is the alignment of thoughts with events, the convergence of inner and outer worlds. Some see it as pure chance, the brain's tendency to find patterns. Others see it as evidence of deeper connections, hidden harmonies in the fabric of reality. Whatever its explanation, the feeling it creates is real. It is the sense that you are not entirely separate from the flow of the world, but somehow entwined with it, as though your mind and the cosmos are dancing in step for a moment. Neuroscience offers one perspective. The brain is a pattern-seeking organ. It is constantly scanning for connections, linking events to meaning. When two unrelated things happen close together in time, the brain often interprets them as connected. This is useful for survival. Recognizing patterns allows you to predict and respond to the world, but it also means you are wired to notice coincidences. The improbable feels meaningful because your brain evolved to care about timing and connection. Physics offers another perspective. The universe itself is built on coincidence and timing. The very existence of life depends on a series of alignments. The Earth happens to orbit at just the right distance from the Sun for liquid water to exist. The Moon happens to be the right size and distance to stabilize Earth's tilt, moderating the climate. Stars happen to fuse elements in a way that produces carbon, the basis of life. None of these coincidences were designed, but together they create the conditions for consciousness to emerge. In this sense, your very existence is the result of cosmic synchronicity. Psychology and physics converge here. Your brain is tuned to notice coincidences, and the universe is structured by countless alignments that make life possible. When the two meet, when an inner thought coincides with an outer event, you experience a moment of synchronicity. Whether it is chance, pattern recognition, or something deeper, the effect is the same. A sense of connection between mind and cosmos. It is worth reflecting on how often timing shapes meaning. A word spoken at the right moment can change a relationship. An idea arriving just when you need it can alter the course of your life. The same word or idea arriving at another time might pass unnoticed. Meaning is not only about content but about timing. The cosmos knows this too. A star exploding billions of years ago sends light across space, and only now does it arrive in your eyes. The timing makes it meaningful. You're seeing an event long gone, yet alive in this moment because of cosmic coincidence. Synchronicity also reveals itself in collective experience. Think of cultural moments when ideas seem to emerge simultaneously in different places. Scientific discoveries sometimes occur in parallel, with researchers working independently arriving at the same insight almost at the same time. Newton and Leibniz both developed calculus. Darwin and Wallace both described natural selection. These coincidences may be explained by shared conditions, similar data, similar tools, similar questions. but they still feel like synchronicities, ideas whose time had come. The world seemed ready, and the minds attuned to it responded together. In personal life, synchronicities often feel like whispers from the universe. They seem to nudge you, suggesting direction, as though chance events carry guidance. Even if this is only interpretation, it can be powerful. It reminds you to stay open, to pay attention, to see meaning in unexpected places. And in doing so, it links you emotionally to the cosmos, weaving your inner story into larger rhythms. From a scientific angle, synchronicity can be seen as the overlap of two systems, the brain's inner rhythms and the world's outer rhythms. When they align, you notice. When they don't, you pass by without awareness. This is not unlike resonance in physics, when two systems vibrating at the same frequency amplify each other. A swing moves higher when pushed in time with its natural rhythm. A glass shatters when sound resonates at just the right frequency. In the same way, a thought and an event resonate when they coincide, amplifying meaning. The parallel to the cosmos deepens here. Galaxies form when matter resonates with gravity. Stars burn when pressure and fusion balance. Planets orbit stably when rhythms align. Resonance is everywhere in the universe, and it is everywhere in the mind. Synchronicity is resonance experienced subjectively, the alignment of inner and outer cycles into a shared moment. What does this say about your connection to the universe? It suggests that your life is not only influenced by cosmic matter and energy, but also by cosmic timing. The same laws that produce eclipses and planetary orbits shape the rhythms of your body and mind. And when those rhythms align with events outside you, the result feels meaningful. Synchronicity is not a mystery imposed on reality. It is reality experienced in rhythm. Reflecting on this can change how you move through the world. Instead of dismissing coincidences, you can see them as reminders of connection. Instead of assuming randomness is empty, you can see it as possibility. Synchronicity does not prove fate or cosmic design, but it shows that timing matters, that meaning is not only in things but in when they occur. And in that sense, synchronicity is one more bridge between mind and cosmos, another way the brain reflects the universe. If coincidences reveal hidden timing, what about the future? Can we sense it, anticipate it, dream it before it arrives? Is intuition another expression of the brain's connection to the cosmos, a way of glimpsing patterns not yet visible? When we speak about consciousness, it is tempting to treat it as something separate from the rest of nature, as though it is an extra layer added on top of the physical world. We feel awareness as intimate, private, and immediate, so different from the distant stars or the silent pull of gravity. Yet when you step back, a different picture emerges. Consciousness is not outside of the cosmos. It is part of it, an expression of the same processes that shape galaxies and atoms. To call it a cosmic phenomenon is not to diminish it. It is to place it in its rightful context, as a feature of the universe itself. Consciousness is not made of different matter. The neurons that give rise to your awareness are built from the same elements that form stars and planets. They are powered by the same forces, electromagnetism, gravity, nuclear interactions that govern the cosmos. What makes the brain distinct is not its ingredients, but the way those ingredients are organized. Out of networks, rhythms, and patterns, a new property emerges, the feeling of being, the sense of I. Emergence is a principle the universe knows well. Hydrogen and oxygen, when combined, produce water, a liquid with properties neither element possesses alone. Billions of neurons, when interacting, produce awareness, a property no single neuron holds. The cosmos is full of such emergent properties. Consciousness is one of them. To see consciousness as a cosmic phenomenon is to recognize it as natural, not supernatural. It does not defy physics, but arises from it. It is not a ghost in the machine, but but a process the machine produces. When a star fuses hydrogen into helium, it releases light. When neurons fire in patterns, they release awareness. Both are lawful outcomes of physical processes. Both are ways the universe expresses itself. Yet consciousness is unique in that it allows the universe to know itself. Stars burn without self-reflection. Galaxies spin without awareness. But brains, once they evolve to a certain complexity, generate minds that ask questions. When you wonder about the stars, it is not something outside the universe doing the wondering. It is the universe, through you, reflecting on itself. You're not separate from the cosmos, standing apart to observe it. You're a point within it, turning its gaze inward. This perspective changes the way you see awareness. Instead of treating it as a private possession, you can see it as a continuation of cosmic history. For billions of years, the universe expanded, cooled, and grew structure. Stars lived and died, scattering elements. Planets formed, some with the right conditions for life. Life evolved, competing and adapting, until nervous systems grew complex enough to support thought. And now, after this long chain of events, consciousness appears. Your awareness is not an accident outside of that story. It is one of its latest chapters. The universe has been moving toward complexity, and consciousness is one of the results. Some scientists and philosophers take this further, suggesting that consciousness might be a fundamental feature of reality, not just an emergent one. This idea, called panpsychism, holds that awareness exists in some form at every level, from particles to planets, with human consciousness being a rich expression of a universal property. Others propose that consciousness arises only when complexity crosses a threshold. Either way, the implication is the same. Consciousness belongs to the cosmos, not outside of it. It is worth considering how fragile and yet how robust awareness is. A change in chemistry can alter it. Sleep, anesthesia, or injury can dim it, and yet, when conditions are right, it re-emerges. This suggests that consciousness is not a separate substance, but a state a system enters when it is organized in a certain way. Much like water freezing or boiling depending on temperature, the brain shifts into awareness when its conditions align. It is a phase of matter and energy, not an intrusion from elsewhere. This view helps dissolve the mystery of why consciousness exists. It exists because the cosmos produces it, just as it produces light, gravity, or motion. It is part of the repertoire of the universe. The question then shifts from why is there consciousness at all, to what does it mean for the universe that consciousness exists? The answer may be that the universe gains reflexivity. Through awareness, it can reflect, question, and imagine. It becomes not only a collection of stars and galaxies, but a place where experience happens. Think of the night sky. When you look up and see the Milky Way, you are not simply seeing light. You are having an experience. That experience is as real a phenomenon as the photons hitting your retina. It is not less natural, not less cosmic. The universe produces light, and the universe produces the experience of seeing light. Both are parts of its reality. To call consciousness a cosmic phenomenon is to put it on the same level as the stars themselves. Both belong to the same whole. This perspective also has implications for how we see life elsewhere. If consciousness is a cosmic phenomenon, then it may not be unique to Earth. Just as stars form wherever conditions allow, awareness may arise wherever complexity of the right kind appears. Planets with life may evolve nervous systems. Nervous systems may evolve minds. Minds may generate consciousness. If so, the universe may be full of awareness scattered like stars, each a point where the cosmos looks inward. We do not yet know if this is true, but to see consciousness as cosmic is to open to the possibility. From a personal angle, recognizing consciousness as cosmic can change how you relate to your own mind. You're not a separate observer locked inside a skull. You're a process of the universe, shaped by its laws, carrying its history, participating in its unfolding. Your awareness is not private in origin, it is public, cosmic, born from the same physics that guides galaxies. To reflect on this is to feel both humbled and expanded. You're small, but you're also vast, because the universe flows through you. Some may worry that this view reduces consciousness, making it seem ordinary, but the opposite is true. To see awareness as cosmic is to give it dignity. It means that your thoughts and feelings are not trivial. They're expressions of the universe. The wonder you feel when you look at the stars is the wonder of the stars themselves, channeled through you. The questions you ask about reality are reality asking about itself. This is not reduction but elevation. Consciousness becomes not an anomaly, but a central feature of the cosmos. And this recognition leads naturally to new questions. If consciousness is cosmic, can it expand? Can meditation, reflection, or science widen awareness, allowing the universe to see itself more clearly? Can individual minds connect into collective awareness, just as individual stars connect into galaxies? Could consciousness evolve beyond what we know, becoming as different from human awareness as our awareness is from that of simpler animals? These questions point forward, reminding us that consciousness is not only cosmic but dynamic, still unfolding, still becoming. When you close your eyes and sit quietly, the world outside begins to recede, sounds soften, light fades, movement slows. What remains is the steady rhythm of your breath, the pulse of your heart, the flow of sensations across your body. This act of stillness, often called meditation, is not an escape from the universe but an entry into it through a different doorway. Rather than looking outward at galaxies, you turn inward to the network of your own awareness. And what many have found is that in doing so, the boundary between inner and outer begins to blur. The same expansiveness that you see in the night sky can be felt within the mind. Meditation takes many forms. Some traditions focus on the breath, some on a repeated phrase, some on open awareness of whatever arises. But at its core, meditation is about paying attention in a sustained, intentional way. When you do this, the usual chatter of thought begins to quiet. The constant pull of memories, plans, and judgments softens. In their place comes a sense of spaciousness, of awareness itself becoming wider, less cluttered, more open. It is in this space that the connection between mind and cosmos becomes clearer. The brain in meditation shows distinctive patterns. Imaging studies reveal increased activity in regions associated with attention and regulation, and decreased activity in regions tied to mind-wandering and self-centered thought. In other words, the brain shifts from constant narrative to present awareness. The sense of I as a separate entity diminishes. Instead, there is a feeling of unity, of being part of a larger whole. For some, this is described as merging with nature, with the cosmos, with something vast and timeless. For others, it is simply peace, a sense of resting in awareness without needing to grasp or control. The parallels with the universe are striking. The cosmos too is expansive, boundless, unfolding. When you sit in meditation and feel awareness expand, you're experiencing on a small scale what the universe embodies on a large one. Openness without edges, presence without end. The space within mirrors the space without. Both are vast, both are dynamic, both are filled with patterns that arise and dissolve. Meditation also reveals the flickering nature of thought. As you sit, you notice how thoughts arise unbidden, stay for a moment, and pass away. They appear like stars in the night sky, sudden, bright, and then gone. Normally you're so caught up in them that you don't see this process. But in meditation, slowing down, you begin to notice the rhythm. Awareness is not a steady stream, but a field in which events appear and vanish. This mirrors the universe itself, where particles flicker in and out of existence, stars are born and die, galaxies form and dissolve. In both cases, impermanence is the rule, not the exception. Many who practice meditation describe experiences of boundlessness. The sense of the body as a rigid boundary softens. Awareness feels less confined to the head and more spacious, as though it fills the room or stretches outward indefinitely. This can be interpreted in many ways: psychological, neurological, or spiritual. But whatever the interpretation, the experience is real. It suggests that the mind has the capacity to feel itself as vast, to resonate with the openness of the cosmos. The expansion of the universe finds its echo in the expansion of awareness. There is also a temporal element. Meditation alters the perception of time. Minutes can feel like hours, or hours like minutes. Sometimes time seems to slow, each moment stretching into fullness. Other times it seems to disappear, awareness resting outside of sequence. This too reflects the cosmos, where time is relative, stretching and contracting depending on speed and gravity. In meditation, the brain generates its own relativity, reminding you that time is not as fixed as it seems. Both cosmos and mind play with time, shaping it into different experiences. From a scientific perspective, meditation strengthens networks in the brain that support attention, empathy, and regulation. It reduces stress, lowers blood pressure, and enhances well-being. From a philosophical perspective, it opens awareness to the fact that the self is not as solid as it seems. And from a cosmic perspective, it shows that the mind is capable of experiencing itself as part of something vast. These perspectives are not in conflict. They are different lenses on the same truth. Meditation connects you more deeply to the fabric of reality, both inner and outer. Think of the universe expanding since the Big Bang, galaxies drifting farther apart as space itself stretches. Meditation mirrors this expansion inwardly. Your awareness, usually contracted around narrow concerns, stretches open, making room for everything without resistance. The expansion of the cosmos and the expansion of awareness are not literally the same, but they resonate. Both reveal that space is not empty, but full of potential. Both reveal that openness can hold everything. Meditation also highlights the illusion of separation. Normally, you feel like an isolated individual looking out at a world distinct from you. But as awareness quiets, that boundary weakens. Sounds, sensations, and thoughts all arise within the same field of awareness. The distinction between inner and outer becomes less clear. You realize that your experience of the world is not separate from your mind, but part of it. And if the mind itself is part of the universe, then in a very real way there is no separation. You are the cosmos experiencing itself from within. This recognition can bring a sense of peace. Instead of struggling against the universe, you rest in it. Instead of feeling small against the stars, you feel connected to them. The atoms in your body, the rhythms of your brain, the thoughts in your mind, all are expressions of cosmic history. Meditation lets you feel this not only as an idea, but as a lived reality. It is not about believing that you are connected to the cosmos. It is about experiencing that connection directly through the expansion of awareness. If awareness can expand inwardly to feel as vast as the universe, what happens when it turns outward again? Can the observer change the observed? Does the act of awareness shape reality in subtle ways, just as observation shapes outcomes in quantum experiments? Is consciousness not only a reflection of the cosmos, but also a participant in its unfolding? One of the most puzzling findings in modern physics is that the act of observing can change the outcome of an experiment. In the quantum world, particles behave differently depending on whether they are measured. When left unobserved, they spread out like waves, occupying multiple possibilities at once. When observed, they collapse into definite states, taking on specific positions and paths. This is known as the observer effect, and it has puzzled scientists and philosophers for decades. How can simply looking at something change what it is? What does it mean that the universe responds to measurement? And what, if anything, does this have to do with consciousness itself? The classic demonstration of the observer effect is the double-slit experiment. When electrons or photons are fired at a barrier with two slits, they create an interference pattern on the screen behind it, as though they are waves passing through both slits simultaneously. But when detectors are placed at the slits to see which path each particle takes, the interference pattern disappears. Instead, the particles act like tiny bullets, going through one slit or the other. The only difference is whether or not they are observed. Somehow, the act of measurement changes the behavior of the system. Physicists explain this in different ways. Some argue that observation forces a particle's wave function, a mathematical description of its probabilities, to collapse into a single outcome. Others suggest that particles exist in superpositions of states until they interact with their environment, a process called decoherence, which looks like collapse but is really entanglement with surroundings. Still others propose many worlds interpretations, where every possibility plays out in separate branches of reality. The details remain debated, but the fact remains: observation matters. Now think about what it means for awareness. In daily life, you might assume that the world exists independently of whether you notice it. A tree stands in the forest whether you look at it or not, and at the macroscopic scale, this is true, but at the quantum scale, reality seems to withhold its definiteness until it is observed. This raises profound questions. Is consciousness required for the collapse, or is any interaction with the environment enough? Is the universe in some sense unfinished until it is looked at? And if awareness plays a role, does that mean the mind is more deeply connected to the cosmos than we imagine? Some interpretations of quantum mechanics avoid involving consciousness at all. They argue that measurement is just interaction, and awareness is irrelevant. A detector counts as observation whether or not a human looks at the result, but others note that, at the end of the chain, a conscious observer must read the data. The measurement is not complete until someone knows the outcome. In this view, awareness is woven into the very fabric of physics, not as an afterthought but as a participant. The universe becomes definite because it is experienced. This connects with the everyday role of observation in the brain. When you pay attention to something, you change it. Neurons strengthen their connections when they are active together. By observing, you literally rewire your brain. A memory becomes stronger when recalled, because the act of observing it again reinforces its path. Attention alters learning, perception, and even emotion. To observe is not passive, it is active, shaping the very system you're observing. This is true in neuroscience, and it seems to be true in physics as well. The parallels suggest that awareness may not be a small private phenomenon, but part of the larger process by which the universe unfolds. When you look at the stars, you're not simply taking in light. You're collapsing photons that have travelled for millions of years into definite experiences in your brain. Without you, they would remain probabilities. With you, they become memories. The act of looking is not just seeing, it is shaping. It is tempting to take this further and suggest that consciousness creates reality, but that may not be the right conclusion. The observer effect does not mean that thoughts alone make the world. It means that interaction, including conscious interaction, plays a role in how reality is realized. The cosmos is not a fixed stage with actors already set. It is a process in which awareness participates. Your mind is not separate from that process. It is part of it, both receiving and shaping at once. This perspective adds depth to the question of whether your brain is connected to the universe. Not only is it built of stardust, patterned like galaxies, and timed by planetary cycles, not only does it share in quantum fluctuations and rhythms of entropy, it also plays an active role in shaping the universe it perceives. The act of looking is itself a cosmic event. Every photon that enters your eye and is turned into experience completes a journey that began long ago. Every thought you direct alters the pathways in your brain, reshaping the matter that thought is made of. The observer is not outside of the system. The observer is inside, changing it. This realization carries into relationships as well. When you observe another person, really see them, pay attention to them, you change them. Your attention alters their experience just as theirs alters yours. Observation creates connection, resonance, and transformation. It is not only in quantum physics that looking shapes reality. It is in human life too, every time awareness is directed. There is humility in this recognition. You are not omnipotent. You do not control the universe by looking at it, but you do participate. Your awareness is part of the cosmos becoming definite, part of the interplay between probability and actuality. You're woven into the process by which reality takes shape. The cosmos does not unfold in isolation. It unfolds through participation, and consciousness is one form of that participation. If observation plays such a role, what about the future? When you imagine a distant galaxy or picture a future self, are you shaping possibilities into reality? Does attention extend beyond the present, collapsing not just photons but potential paths of time? The mind is not confined to the present. Even as you sit still, listening, your awareness drifts forward and backward. You recall memories from years ago. Imagine conversations that have not yet happened, and place yourself in scenes that exist only in possibility. This ability to project across time is one of the brain's most remarkable features. It allows you to plan, to anticipate, to prepare. It gives you not only a present self, but a future self, a version of you that exists in imagination before it arrives in reality. The cosmos, too, is never only in the present. Every star you see is already in the past. Light from the sun takes 8 minutes to reach you. Light from the nearest star takes 4 years. Light from distant galaxies takes millions or even billions of years. To look outward is always to look backward, to see not what is but what was. And yet, in the expansion of the universe, those galaxies continue to move, their future already unfolding even as their past reaches your eyes. In this way, the cosmos and the mind share a strange relationship with time. Both are stretched between memory and anticipation, between the already gone and the not yet. Neuroscientists describe the brain's capacity for mental time travel as one of its defining traits. The same networks that allow you to remember the past are active when you imagine the future. To picture what might happen, your brain recombines fragments of memory, projecting them into new configurations. This is why imagination feels vivid. It is built from real pieces of experience, rearranged into possible futures. Your mind is like a galaxy of moments, stars of memory linked into constellations that map both what has been and what could be. And just as galaxies stretch across vast distances, so your imagination stretches across vast timescales. You can picture yourself tomorrow, but also in 20 years. You can imagine your descendants, centuries into the future. You can envision civilizations not yet born, exploring stars not yet reached. Your brain, built to navigate daily life, also gives you access to cosmic scales of time. You can hold a distant galaxy in your thoughts as easily as you hold a memory from childhood. The reach is astonishing. This reach across time and space is not limitless, but it is profound. It allows you to learn from mistakes, to plan journeys, to create art and science. It also gives rise to existential reflection. You can imagine your own mortality, the fading of stars, the eventual heat death of the universe. You can picture not just your life, but the span of cosmic history. In this sense, the future self and the distant galaxy are not different in kind. Both are products of imagination. Both are ways the mind stretches beyond the present moment. What's remarkable is how closely the perception of time is tied to memory. Without memory, the future cannot be imagined. Amnesia erases not only the past, but also the ability to project forward. This suggests that time in the mind is not a linear track, but a loop of memory and imagination. You move backward to move forward. retrieving fragments of the past to construct visions of the future. The cosmos, too, reveals time through memory. The light from distant galaxies is a record of their past, preserved in photons travelling across space. To know the universe is to look into its memory. To know yourself is to do the same. This connection extends to the way time bends. In Einstein's theory of relativity, time is not fixed. It flows differently depending on speed and gravity. A clock on a fast-moving spaceship ticks more slowly than a clock on Earth. A clock near a black hole ticks more slowly than one far away. The universe stretches and warps time, making it relative to perspective. The brain, too, bends time. In moments of danger, time seems to slow, every detail sharp. In moments of absorption, hours vanish in what feels like minutes. In boredom, minutes drag endlessly. Time is elastic, stretched, and compressed by context. Both cosmos and mind reveal that time is not absolute, but shaped by conditions. This elasticity opens the door to deeper parallels. Just as relativity allows for time dilation, the brain allows for mental dilation of experience. A future self can feel real even though it does not yet exist. A distant galaxy can feel immediate even though its light left long ago. In both cases, you are living outside of the present, extending awareness across scales. Consciousness collapses distance just as imagination collapses years. The ability to imagine the future also binds people together. Shared visions create communities, just as shared gravity creates galaxies. Nations form around visions of tomorrow. Movements grow from ideas of what could be. The pull of the future is as strong as the pull of matter. It organizes, directs, and shapes. Just as galaxies orbit a common center, humans orbit shared futures. The gravity of time holds both cosmos and society in motion, but the future self is not always clear. Just as distant galaxies are obscured by dust or hidden beyond the cosmic horizon, your own future can be hazy. You can project, but you cannot know. This uncertainty is not failure. It is the nature of time. The cosmos does not reveal its future fully, and neither does the brain. Both hold mystery. Both leave space for surprise. In this uncertainty lies possibility. It is also worth noting how fragile the sense of time can be. Disorders of the brain, such as dementia, can erode memory, and with it the ability to imagine the future. The loss is not only of what has been, but of what might have been. In the same way, disruptions in the cosmos can obscure its future. Dark energy accelerates expansion, making distant galaxies unreachable, hiding their future paths. Both brain and cosmos contain horizons beyond which we cannot see. Both remind us that time is not fully accessible, yet within those limits there is still vast reach. Your brain can imagine billions of years into the past and billions into the future. It can hold the image of the early universe, a hot plasma of particles, and the image of a far future universe, cold and dark. It can picture galaxies colliding, stars dying, black holes evaporating. This reach is not trivial. It shows that consciousness is not confined to immediate survival. It has grown to encompass cosmic scales. You can think the universe because you are of the universe. Your neurons, themselves the products of cosmic time, now carry cosmic time in thought. This leads to a profound recognition. Your future self and a distant galaxy are connected in the same way. Both exist in potential. Both are known through imagination. Both are shaped by time's flow. To imagine the future self is to extend awareness forward. To see a distant galaxy is to extend awareness outward. Both are exercises in stretching the boundaries of mind. Both reveal that consciousness is not limited to the here and now, but reaches into scales that transcend the body. If your brain can project across time and space, if it can imagine futures and hold galaxies in thought, what happens when those projections converge? What happens when human imagination turns not only to personal futures, but to cosmic ones, envisioning humanity reaching the stars? Could this merging of inner projection and outer reality be another way the cosmos evolves, through minds that imagine and then act, turning possibilities into existence? Across cultures and centuries, humans have looked at the night sky and seen not just stars but reflections of themselves. The constellations are perhaps the clearest example. Patterns of stars became hunters, animals, heroes, and gods. The heavens served as a mirror for earthly life, a place where myth and meaning could be projected. Long before telescopes revealed galaxies and clusters, long before physics described black holes and cosmic expansion, people sensed that the mind and the cosmos were connected. They turned the universe into a canvas for imagination, filling the sky with stories that reflected human thought. This tendency is not accidental. The brain is a pattern-seeking organ, built to make sense of the world by finding structure. Faced with the seemingly random scatter of stars, people found lines and shapes. The myths built around them reflected values, fears, and hopes. Orion the hunter, the Great Bear, the Pleiades, all of these were ways of mapping the sky onto the human experience. The stars became a mirror for the mind, a way to place inner stories onto outer space. Science has not erased this mirroring, it has deepened it. When we study the brain and the cosmos side by side, the parallels are striking. The large-scale structure of the universe, the cosmic web of galaxies and dark matter, resembles the network of neurons in the brain. Both are built from nodes connected by filaments. Both balance randomness with order. Both show emergent patterns far greater than the sum of their parts. This resemblance is not just visual, but structural. The cosmos and the brain both rely on distributed networks to create coherence. In galaxies, gravity holds the web together. In the brain, electrochemical signals do the same. The universe is vast and the brain is small, but the architecture is mirrored. Even the elements are mirrored. The carbon in your neurons, the oxygen in your blood, the calcium that carries signals across synapses, all were forged in stars. The matter that forms thoughts is the same matter that forms galaxies. This is not metaphor, it is chemistry and physics. When you look at the night sky, you are seeing the ancestors of your own brain. The stars did not just inspire myths, they gave birth to the atoms that allow you to imagine myths at all. The brain is not separate from the cosmos, it is a miniature cosmos, reflecting its history and its structure. And then there is wonder. Both brain and cosmos evoke it, because both are so vast, so complex, and so full of mystery. The more we learn, the more we realize how much remains unknown. In neuroscience, we do not yet fully understand how neural activity produces subjective experience. In cosmology, we do not yet know the nature of dark matter or dark energy. Both fields confront us with limits to our knowledge, and in those limits, we encounter awe. Wonder is the recognition of vastness, whether it is within the skull or beyond the stars. Myth, science, and wonder intertwine here. Myth provided the first reflections, mapping human stories onto the cosmos. Science provides deeper reflections, revealing that the brain and the universe are built from the same principles. Wonder arises from both, reminding us that the mirror is not complete. That much remains hidden. To see the brain as a mirror of the cosmos is to see human thought as part of a larger whole, reflecting not only culture but nature, not only imagination but physics. This recognition changes how we see myths themselves. They are not just fanciful stories, but early attempts to express the deep intuition that mind and cosmos are connected. When ancient people told stories about the stars, they were not wrong to feel kinship. They were expressing in symbolic language what science later confirmed. The brain and the cosmos share structure, substance, and mystery. Myth was the first mirror. Science is the second. Wonder is what bridges them. The mirroring goes deeper when you consider how both brain and cosmos contain layers of reality, some visible, some hidden. The visible stars are only a fraction of what is in the universe. dark matter and dark energy dominate, unseen but essential. The conscious mind is only a fraction of the brain's activity. The unconscious and subconscious, hidden layers of thought, dominate beneath awareness. Both mind and cosmos are built on hidden foundations. Both remind us that the surface is not the whole. Even time is mirrored. The brain experiences time in rhythms, cycles of sleep and wake, of attention and rest. The cosmos experiences time in cycles of rotation, orbit, and expansion. Both flow irreversibly forward, guided by entropy, but both also create local order, moments of coherence within the flow. Memory in the brain, structure in the cosmos, these are ways of resisting dissolution, of holding shape against time's current. And in both cases, reflection is central. The brain reflects on itself, producing awareness. The cosmos reflects in the brain, producing science and myth. When you look at the universe and wonder about it, you are looking into a mirror. The neurons that wonder are made from the stars being wondered about. The symmetry is profound. You're the mirror and the image at once. This perspective has practical implications too. When you study the brain, you're also learning about the cosmos, because the principles are shared. When you study the cosmos, you're also learning about the brain, because the matter and the patterns overlap. The divide between inner and outer dissolves. Both are expressions of the same reality. Both are mirrors of each other, and this recognition invites us forward. If the brain mirrors the cosmos, then the search for knowledge in both directions is the same search. To understand thought is to understand the universe reflecting on itself. To understand the universe is to understand the matter and patterns that make thought possible. Myth, science, and wonder are not separate paths but aspects of the same journey. If the brain mirrors the cosmos in structure, substance, and mystery, what does that mean for meaning itself? Does the universe have purpose, or is meaning something the brain projects onto it? Is wonder a signal of connection, or is it only the brain's way of coping with immensity? As we come gently toward the end of this long journey, it's worth pausing to notice what has been unfolding all along. From the beginning, this question has been guiding us quietly. Is your brain connected to the universe? We've moved through patterns of neurons and galaxies, through electricity and light, through rhythms of thought and rhythms of stars. We've explored dreams, memory, entropy, and even the hidden matter of mind and cosmos alike. And now, here you are, breathing, listening, and letting these words settle. The simple truth is that your brain has never been separate from the universe. It was not placed into existence as an exception. It is a continuation, a development of the same processes that have always been at work. Every atom inside you once belonged to stars. Every signal in your neurons follows the same laws that guide starlight and gravity. Every rhythm in your mind echoes the turning of Earth and the expansion of galaxies. You're not apart from the cosmos trying to connect back to it. You are the cosmos becoming aware of itself. When you look at the night sky, it can seem impossibly vast. The stars look distant, scattered across darkness, unreachable. But that feeling of distance is only half the story. Those same stars live inside you. Their matter flows in your veins. Their history is written in your bones. Their light enters your eyes and becomes thought. The sky is not out there. It is also in here, reflected in every cell of your body and every flicker of awareness. The separation is an illusion. The connection is constant. This connection does not depend on knowledge. Long before science measured atoms or mapped galaxies, people felt the bond. They told stories about constellations, built temples aligned with stars, and treated the sky as a mirror for the soul. They may not have known about dark matter or quantum fluctuations, but they knew something equally important, that the universe was not just scenery. It was part of them. That intuition still lives in you. Science confirms it with detail, but the feeling itself is timeless. You can sense this connection in the smallest moments. When sunlight warms your skin, it is not just warmth. It is the energy of a star travelling across space, absorbed into your body. When you breathe, you take in oxygen made in stars feeding your cells. When you think, the electrical currents in your neurons are the same kind of currents that move through lightning and nebulae. When you sleep and dream, your mind creates inner worlds that echo the larger one outside. The connection is not abstract. It is physical, immediate, and constant. And then there is the silence. The universe is vast, but most of it is quiet, empty of sound, full of stillness. Your brain, too, is filled with quiet spaces. Between each neuron spike is a pause. Between each thought is a silence. Meditation teaches you to rest in that space, to feel awareness itself without needing to fill it. The silence of the cosmos and the silence of the mind are the same kind of silence, a space full of possibility, holding everything. In that silence, wonder arises. It is not forced. It simply comes when you feel the immensity of what you are part of. Wonder is not only about stars and galaxies. It is about the fact that you exist at all, that atoms can become awareness, that the universe has produced something that can ask questions about itself. The wonder you feel is not separate from the cosmos. It is the cosmos, resonating in your awareness, reflecting on its own existence. This is the silent connection. It does not shout. It does not demand belief. It is simply there, in every breath, every photon, every flicker of thought. You're not a stranger in the universe. You're at home in it. You have always been. The stars are not only above you, they are within you. The rhythms of the cosmos are not only outside, they beat in your brain and heart. The silence of space is not only distant, it lives in the pauses between your thoughts. And as you rest with this, you may notice that the question we began with, whether your brain is connected to the universe, no longer needs an answer. The connection has been here all along, not something to prove, but something to remember. Every moment of awareness is proof. Every glance at the sky is confirmation. Every breath is participation. You do not have to reach for the universe. You're already woven into it. So as the words begin to slow, you can simply rest in that recognition. You are the cosmos, alive and aware. You are the stars, breathing and thinking. You are the silence, holding everything. And in that silent connection there is peace. Thank you for spending this time here, letting your mind wander through stars and thoughts, through science and silence. If you found this journey comforting, you're always welcome to return whenever you'd like more company from the cosmos. You can drift off now, knowing the universe is not far away. It's in your breath, in your heartbeat, in your very awareness. If you'd like to hear more explorations like this, you can subscribe, and the next time you need something gentle to fall asleep to, it will be waiting for you. Until then, rest well, and may the quiet of the universe keep you safe tonight.